Users, teams, roles, sharing. Is your permission system a tangled mess?
Everybody is talking about RAG. How do you make sure that they're only getting access to the things that they should have access to? Sensitive employee data, financial data, plans for the future, strategic things.
One permission system with unlimited possibilities. AuthZed is that solution for you.
SpiceDB takes a look at this practice of authorization.
We have a lot of internal documentation, and the idea is to attack them on SpiceDB.
And tries to give us a better data model for doing this at any level.
We want to be sure that you have access to specific documents. We want to be sure that it's restricted properly.
Eliminate authorization silos and simplify your architecture with a centralized permissions platform. One authorization system for your entire application ecosystem.
I'm going to teach you about the primitives that you can use to build schemas in SpiceDB.
Model context protocol, performance and load testing for SpiceDB. How Discord does their user permissions.
AuthZed delivers a centralized authorization system's flexible configuration language is built for global scale and performance with strong consistency guarantees. AuthZed, stop building AuthZ, start building value.
Hey, welcome to AuthZed is 5, the authorization infrastructure event. I must admit that video made me look very cool. So my name is Sohan Maheshwar. I'm going to be your host for today. And today we're doing two things. One, we're celebrating AuthZed's 5th birthday. AuthZed's moving from a preschooler to a grade schooler. So it'll be interesting to see what grade school has in store for us here at AuthZed. And two, more importantly, we are going to be talking about authorization. Yes, we have a great lineup of speakers today, including Artie from Canva. We have Joey, the CTO of AuthZed, talking about something cool that he's been working on. We have Andre from Turo that will be talking to us as well. And we also have Andy Pavlo, who's the professor of databaseology. I'm glad I got that correct on the first try, who will be talking to Jimmy, one of our co-founders. So we have a lot of cool things in store. Some housekeeping first and foremost. If you haven't signed up already, make sure you sign up for the limited edition swag. So if you sign up at that link, you'll get an email and you will get limited edition swag. This photo might not necessarily be indicative of what the swag looks like, but it comes pretty close. So, go ahead and sign up as quickly as you can. And we will be streaming for the next couple of hours, about 2.5 hours. So we have a great agenda for you today. Let us know in the comments where you're watching from and what you do in the authorization space. And we will soon hear from Jake, our CEO, about the past and the present and the future of authorization. So stay tuned, and here comes Jake.
Hi everybody, and welcome to the first ever AuthZed Authorization Infrastructure event. We're taking this opportunity to celebrate our 5th birthday, but also to talk about all things authorization infrastructure. We've got a great lineup for you today, but before we get to that, we need to tell you a little bit about how we got to where we are. So we're going to cover some of the most important events in our company's history. So buckle up, because we're going to be doing a little bit of time traveling. Before I can talk about the AuthZed story, I need to talk about how we as founders identified the problem. And we identified the problem, as most founders do, through experiencing it ourselves. So way back in 2013, Joey, who's our current CTO, and I built and launched a product called Quay. Quay was the first private Docker registry. And when you really think about it, the difference between a private Docker registry and a public Docker registry is authorization. So our requests were often taking the form of, how do I add organizations to the platform? How do I add teams? How do I model teams that are a part of other teams? And these features were really features that we had to deliver in order to deliver on the promise of being a private Docker registry. We were constantly struggling with our authorization engine because we had chosen something that wasn't quite as flexible as what we needed. We chose to do authorization using joins in our database. Things like recursive queries prohibited us, or the lack of recursive queries prohibited us from being able to do recursive nested teams, for example. Eventually, the Quay journey culminated in being sold to CoreOS in 2014. We stayed with CoreOS from 2014 until their eventual sale to Red Hat in 2018. While at CoreOS, we were still building out Quay into a massive business. You can actually still go and buy Quay from Red Hat today. It's called Red Hat Enterprise Quay. And we were also working on CoreOS's product called Tectonic. Tectonic was, if you think about it, the first unbundled cloud provider. So the idea for Tectonic was that you would bring in compute, network, and storage using Kubernetes, and then you would layer on higher level services. Think your blob store, document database, media compression engine. You'd bring in those services using what we called operators. And operators were software that runs other software. But one of the challenges that we always had with Tectonic was, how do we replace the IAM service that any other cloud provider would have if we can't even enumerate the higher level services that the user is going to bring to the platform? How do we do that in a way that's still fast and scalable? Ultimately, like I said, we ended up selling CoreOS off to Red Hat, and we were at Red Hat in the summer of 2019. So in the summer of 2019, Google released the Zanzibar paper. The Zanzibar paper details how Google does fast, flexible, reliable authorization for all of the internal services at Google. So that's Google Docs, YouTube, Google Cloud IAM, the rest of the Google Drive suite, Google Groups themselves. And we read the paper and we really recognized that they were onto something special. In this paper, they detailed a way to build an authorization system that could run with maximal uptime, huge amounts of scalability. Google runs it at millions of queries per second across billions of users and tens of billions of objects, and in a flexible way that it could support all of the services that I was just talking about. After reading this paper and mapping that back to the problems that we had seen at both CoreOS and our own product, Quay, and then eventually at Red Hat, we decided, let's go and take the concepts from this paper and bring them to the rest of the world so we can solve authorization for everyone. And that brings me to August of 2020, which is when our company was founded, 5 years ago today. We were on a mission to fix access control for everybody. We believed that our experience gave us some unique insights into the problem, and the fact that we had tons of experience building infrastructure, tons of experience with system programming, and building scalable services made us uniquely positioned to solve this very tricky problem for the rest of the world. We took the concepts that we were pursuing for fixing access control for everybody using the concepts in the Zanzibar paper, and we applied to the winter 2021 batch of Y Combinator. This is a really unique time in Y Combinator's history. So this was their first fully virtual batch, and we all had a lot of learning to do together about how to run a program like Y Combinator virtual. They've since moved back to in-person, but the program was great. We learned a lot, and at the end of the program, that culminated in our seed round of fundraising, led by our wonderful partners over at Workbench. Fast forwarding a little bit to June of 2021, I had the opportunity to present my now favorite paper, Zanzibar, to the Papers We Love YouTube audience. So Papers We Love, if you're not familiar, is a group, it's a set of meetups around the world where people present on papers that they find truly inspiring. Like many other things, Papers We Love was running virtual. But I thought this was a great opportunity to show the world about why I was excited about the concepts of Zanzibar and why it's such a foundational paper and something that the concepts can really apply broadly. That video went on to get about 18,000 views across AuthZed and Papers We Love's YouTube accounts, which was a great stepping point for people to learn about Zanzibar. Fast forwarding a little bit to August of 2021, we decided that we needed a really tangible way, a really practical way for people to understand the concepts that we were talking about and the concepts that we were trying to bring to market. So we said, how can we teach people in a way that they can actually relate to? One of the things we realized is that all or virtually all developers know how GitHub works, right? We've all interacted with it. We know how we can store code. We know how we can interact with repositories, the various access permissions, access levels, etc. So Jimmy, our CPO, and I decided, let's model the GitHub permissions video, or let's create a video modeling GitHub permissions and post it to YouTube. So we did it in one take. We just went through and we went into the AuthZed playground and we modeled GitHub permissions live. This video went on to get 14,000 views on YouTube. And now to this day, when I go into a customer call, people will say to me, "Oh my gosh, I already know you because I watched your modeling GitHub video on YouTube." Another fun tidbit about this video was that the authorization lead at GitHub commented to his coworker, "Wow, they just open sourced our authorization model for the whole world to see." So that was really, really interesting to hear that level of validation from somebody who was so in the know about the problem space. Moving on a bit to late September of 2021, we decided that we needed to open source the core of our offering. So in 2021, the idea of opting for a commercial closed source database seemed rather alien. So we decided that open source was the best way to get the word out there and really to help the community understand that fixing access control was our first priority. When we open sourced SpiceDB, we were on top of Hacker News for like 24 hours. And this was really what introduced the world to AuthZed and SpiceDB. Then people would go and dig into everything that we had created so far. But it was a really great opportunity for the world to learn about and even discuss the concepts that we were bringing forward and the software that we had created to do so. Fast forwarding a little bit to July of 2022, we created a product and launched a product called AuthZed Dedicated. Fun tidbit about AuthZed Dedicated is that we launched the product 2 weeks after we already had a paying customer. The customer decided that what we were doing was really, really important and something that they really needed, and they were willing to accept it in a pretty underdeveloped state. AuthZed Dedicated, the product, is based around the idea that we'll put an entire copy of our stack right next to your workloads. So why would we do that? It seems like a painful way to run a service. The reason is we wanted to be able to offer our customers minimal latency. So when you're making an authorization request, you really want to make sure that you're minimizing latency to give the end users, right, our customers' users or our customers' customers, we want to give them the best possible experience. It also was a way to eliminate noisy neighbors. When everything is dedicated to the customer, there's no resource contention or anything like that to deal with. And we were able to offer it on all of the cloud providers using a private networking feature that gave them the security to treat this as if it was their own infrastructure, but the ability to basically pass off the complexity of managing it and running it to our team. And this was really an inflection point for the company. So to this day, AuthZed Dedicated is our flagship product, and it's the way most of our customers are operating our services today. Fast forwarding again a little bit, I want to take you to May of 2023. In May of 2023, we were approached by a company you may have heard of, Netflix. And Netflix had a simple ask. They said, "We like the concepts of SpiceDB, but we have a few very tangible ways that we need to be able to bring the concepts of ABAC, or attribute-based access control, over to SpiceDB and solve some very strategic problems." The good news was we already had our caveats feature designed, and we pointed the team over at Netflix to the caveats feature and said, "Does this sound like what you need?" The design for it was done in the open. And the Netflix team said, "Yeah, that sounds like exactly what we need." And so we decided to embark on developing this feature together. So Netflix agreed to be a design partner for the caveats feature. And all of the work culminated in a blog post that we wrote together about our experience working together. And this was another inflection point for the company because a lot of the objections that people have about buying from a small startup go away when you hear the phrase, "If it works for Netflix, it'll work for me." Moving on a little bit to February of 2024, we launched a product called Materialize. Materialize is an advanced product for SpiceDB and AuthZed users. Materialize allows us to basically compute the transitive closure of who has access to what. And it lets us answer questions like, I want to show the 10 most recently edited documents, which is very easy to do using your normal relationship database. But I want to show the 10 most recently edited documents that I have access to. And when you have a complicated access control scheme, that can actually be quite difficult to do. And so we created Materialize to solve this niche, to solve this need. We pre-compute the exhaustive list of who has access to what. And we create an API where users are able to syndicate what's happening in their permissions database over to their main database so that answering those questions becomes as simple as a join with the table that represents who has access to what. And we watch for changes in SpiceDB, and we syndicate those changes over to that main database. So the main database is always kept up to date, regardless of how complicated that policy is. Like I mentioned at the beginning, this is a very critical feature for some of our biggest customers. And it's also only available to our SpiceDB customers who have a demonstrated need and who are quite sophisticated. That brings us to June of 2024, where we announced our Series A fundraising. I don't want to bore you with the machinations of startup life, but this is a really interesting validation point that proves that investors are seeing the excitement that we're seeing in the market. Moving forward a little bit to September of 2024, we published the results of a really impressive scale test that we ran in our team. We took AuthZed dedicated to 1 million queries per second on top of CockroachDB, which is a flagship data store provider for us. We took our system as far as we dared pay for, so we could have taken it farther. There was no signs of it slowing down. But what this meant was that the scalability of AuthZed was no longer a question for our customers. And all of a sudden, we noticed that everybody else who was trying to play in the market got very quiet about how scalable their systems were. All right, let's move on to January of this year. So January of 2025, we launched our expiring relationships feature. This was driven by a customer need. So one of our largest customers came to us and they said, we understand that we can do expiring relationships with your caveats feature, but we would really like something native built into the platform itself. If you build expiring relationships using our caveats feature, it would involve a manual cleanup process. And it's not even trivial to figure out which relationships need to be removed after they expire. So what we did is we went and we designed this in concert with the customer, and we built it and we launched it into our system. And now it's available for everybody to use. Moving forward to very recently, in June of this year, we launched AuthZed for AI, or as we call it, AI authorization. This is not something we initially set out to do, but we looked at our portfolio of customers, and we realized that we're already helping some major AI players with their authorization infrastructure. So we decided to really tell the world about how we're doing that and what some of the best design patterns are for AI authorization infrastructure. And you can see that at our AI authorization page right on our landing page. And that brings us to today. Today, I am excited to unveil that we have been working on a version of AuthZed dedicated that we run called AuthZed Cloud. The biggest difference between AuthZed dedicated and AuthZed Cloud is that AuthZed Cloud can be self-serve. You can go and sign up for it today. In fact, I encourage you to go and sign up for it today. And we're bringing the power of AuthZed dedicated into a more traditional infrastructure as a service package. So unlike AuthZed dedicated, where you need to be involved with our team, we have to sign a contract, and then we go and deploy infrastructure on your behalf, with AuthZed Cloud, you can go onto the platform, put in a credit card, and be off to the races with AuthZed Cloud today. No involvement from our team required. We encourage everybody who's watching this video today, to apply for credits. We'll give you information about where and how to apply for credits. And the credits are enough for you to get started with AuthZed Cloud and really verify that this is the model that would be perfect for your business to take your business's scalability to the next level. To show you more about AuthZed Cloud, I'd like to pass it off to Sam to do a demo. Come on over, Sam.
Thanks, Jake. Hi, everyone. Let's use our imagination and some AI tools to demonstrate the power of using AuthZed Cloud as your authorization infrastructure. Let's dive in. I'm a product manager at Z Suite, a popular consumer app with millions of users. Recently, we noticed something interesting. A lot of businesses were using our product and asking for enterprise features, especially around permissions and access control. Our development team is amazing at building consumer features, but authorization? That's a different story. We needed to support complex organizational hierarchies, role-based access, and we needed it done yesterday. Instead of having my team become authorization experts, I decided to delegate this to infrastructure. That's where AuthZed Cloud comes in. Authorization infrastructure on demand when you need it. The approach is straightforward. We build our app, integrate with AuthZed Cloud to define and enforce permissions, and let AuthZed handle the necessary operations and scaling. We already have authentication handled, so now we just need to spin up our authorization infrastructure. To get started, I signed into AuthZed Cloud and created our first permission system in just a few clicks. next step was defining our authorization model. Using their schema language, I could define our organizational structure: users, teams, resources, and all the relationships between them. It's like writing a database schema, but for permissions. Then came integration. Our developers wrote relationships to define who belongs to which teams and started making permission checks in our app. And just like that, authorization was working. Our business users could now manage users and groups and restrict access with role-based access controls. The enterprise version launched and was immediately successful. But how could I tell if our authorization infrastructure was keeping up? AuthZed Cloud's monitoring made it easy. I could see audit logs of every permission check, get performance insights, and track usage patterns. And when I saw we were running hot, high request volumes, peak usage times, scaling was just a matter of adjusting our permission system configuration. Here's where it gets really powerful. We've been working on a new app. Let's call it Z Suite Analytics, that we wanted to add to our business product suite. With traditional approaches, we'd need to rebuild permissions from scratch. But with AuthZed Cloud, I could just point the new app to our existing permission system. All our organizational data, user roles, team structures, everything was already there and ready to use. What started as a quick solution to enterprise requests became our authorization foundation. We went from 0 to enterprise-ready permissions in days, not months. Our developers stayed focused on building great features while AuthZed Cloud handled the complexity of authorization. And as we continue growing our app suite, our authorization infrastructure grows with us. Sometimes the best way to move fast is to delegate to infrastructure that's already built for scale.
All right, Sam, thanks for that demo. I'd love to give a huge shout out to our engineering team for being able to take all of the best parts about AuthZed Dedicated and make them available in AuthZed Cloud as a more traditional infrastructure as a service package. I encourage you all to sign up, but don't leave and do that just yet because we have a great show for you today. So we have Artie Shevchenko from Canva and Sanches from Turo talking a little bit about how they're using AuthZed as authorization infrastructure in their companies. We've also got Andy Pavlo, who's an esteemed databases professor out of Carnegie Mellon University. He's like the OG databases professor. So I definitely encourage you to stick around for that. He'll be talking about the intersection between databases and AI. And we've also got a few opportunities to peek behind the curtain for what we're working on at AuthZed and what we'll be launching next. So those will be interspersed throughout the talks. In the future, we'd love to hear from you if this event was valuable and if we should host more of these. So let us know in the chat. I'll be sticking around, so if you have any questions, I'll be able to answer those questions either in the chat or maybe live at a session in the end. And enjoy the rest of the show.
Hey, Jake, thank you so much. That was great. So, folks, you heard it. This is officially announcing the launch of AuthZed Cloud. So, Jake did mention the Cloud Credit Starter Program. So, check on, I'm going to put the link right here. That's authzed.com/cloud/starter program. And if you sign up and if you're accepted into the program, you get up to a month of AuthZed Cloud credit at no extra cost. So check out the Cloud Starter program, and yeah, we'd love to hear from you about it. Also, if you want to sign up to Cloud, you can go out to authzed.com/cloud/sign up as well. Now, Jake did mention about the evolution of SpiceDB, and SpiceDB is completely open source. There's one thing that you need to know, which is that we wouldn't have gotten here without the contributions of lots of folks in the community. So I actually thought I'll take this moment to shout out a few names from the community who have both contributed to SpiceDB, to developer experience tools, to client libraries, and other tooling around SpiceDB itself. Also, just a quick reminder that SpiceDB is completely open source. We also have a very active Discord server where a lot of us AuthZeders hang out. So if you're interested, just check out our Discord server right here. And now for some shout outs. So here are some folks who have contributed to SpiceDB. We have Karthike Saxena. We have Braden Groom, who had joined one of our previous streams from Reddit. We have Chris from PagerDuty. We have Lex, Nicholas from LeBonCoin, I think it is. Sean from GitHub, Maya's Gun, and Jesse from Relian, who's also joined us on a previous stream. All these folks have contributed to SpiceDB in the last year or year and a half. It's not just SpiceDB, of course. We have all the external developer tooling and libraries and frameworks around SpiceDB. So just quickly shouting out all of these folks real quick. We have Dan from who contributed the AuthZed code gen framework. We have Michael, who did SpiceDB.net, which is a .NET framework. We have Shubham, who's done AuthZed_X. We have Ionis, who's done the AuthZed Quarkus client for all you Java folks out there. We have Lurian, who's done the SpiceDB Rust client. We have LinkOrb, which I think is like a collective or a company which has done both SpiceDB PHP and a SpiceDB bundle. We have Michael, who's done something called Chipotle REST, which is again a PHP client, but I love the pun in there. David also contributed to Chipotle REST. And we have Thomas Rickner, who's done SpiceDB Gen. And lastly, we have folks who have created some community tooling around SpiceDB. So I'm going to shout them out real quick before we move on to our next session. We have Mohammad Ijaz, who recently built a SpiceDB UI. So this I thought was very cool. It lets you use a user interface basically to change and update relations and permissions. A very cool open source project right there. We're shouting out Chris, who's done the SpiceDB operator chart. Eitan, who also worked on the SpiceDB operator chart. We have Nicole, who worked on the permissions API. Guillermo, who's done the Authorino SpiceDB integration. We have Thomas, who's done an OPA SpiceDB extension. We have Dominic, whom we have had on our live stream before, who's done like a Keycloak SpiceDB event listener. We have Chip, who's done an extension for VS Code. We have Mike, who's also super active on our Discord, who's done a tree sitter in AuthZed. And we shouted out Thomas before, but another shout out to Thomas again. So any of y'all are watching, thank you so much for contributing towards both SpiceDB and the community and ecosystem around SpiceDB itself. All right, so for the next talk, we have Artie Shevchenko from Canva. Canva is genuinely one of my favorite products. I use it all the time because I don't really have any design capabilities, but with Canva, I feel you can actually be and make good design. So, I love their product. And Canva and Artie are going to be talking about how they solved the dual write problem at Canva when they used SpiceDB. So we will go on to that right now. See you in the next one.
All right, let's talk about the dual write problem. My name is Artie Shevchenko, and I'm a software engineer at Canva. My first experience with systems like SpiceDB was actually with Zanzibar at Google in 2017, and now I'm working on SpiceDB integration at Canva. So yeah, almost 5 years working with this piece of tech. And from my experience, there are two hard things in centralized authorization systems. It's dual writes and data backfills. But neither of them is unique to Zanzibar or SpiceDB. In fact, dual write is a fairly standard process. And when we're talking about replication to another database, it is always challenging. Whether it's a permanent replication of some data to another microservice, or migration to a new database with zero downtime, or even replication to SpiceDB. The good news is centralized authorization systems, they actually do simplify things quite a bit. First of all, as a team now, you own the whole replication process because you own both copies of the data, which makes a huge difference. You're not just publishing an event that other teams would hopefully correctly interpret and apply to their data stores. With SpiceDB, you're fully in control. Secondly, with SpiceDB, you're not replicating aggregates. Most often, it's simple Booleans or relationships, which makes it much easier to reason about the possible inconsistencies. And finally, the volume of replication is also much smaller for two reasons. First, most of authorization data you can store in SpiceDB only once the migration is done. And second, with SpiceDB, you need to replicate just to SpiceDB, not to 10 other services. Well, there are also search indexes, but they're very special for multiple reasons. And the good news is search indexes, you don't need to solve them on client side. Mostly you can just delegate this to AuthZed Materialize. But that said, even with replication to SpiceDB, there is a lot of essential complexity there that first you need to understand, and second, you need to decide which approach you're going to use to solve the do-right problem. The structure of this talk, unlike the topic itself, is super simple. I don't have any ambition to make the do-right problem look simple. It's not. But I do hope to make it clear. So the goal of this talk is to make the problems and the underlying causes clear. And we're going to spend quite a lot of time unpacking what are the practical problems we're solving. And then talking about the solution space, the goal is to make it clear what works and what doesn't. And of course, the pros and cons of the different alternatives. But let's start with a couple of definitions. Almost obvious definitions aside, let's take a look at the left side of the slide, at the diagrams. Throughout the talk, we'll be looking into storing the same piece of data in two databases. Of course, ideally, you would store it in exactly one of them, but in practice, unfortunately, it's not always possible, even with SpiceDB. So when information in one database does not match the information in another database, we'll call it a discrepancy or inconsistency, or I'll simply say that databases are out of sync. When talking about the do-right problem in general, I'll be using the term source of truth for the database that is kind of primary in the replication process. And the second database, I'll call second database. I was thinking about calling them primary and replica, or maybe master and slave. But the problem is these terms are typically used to describe replication within the same system. But I want to emphasize that these are different databases. And also, the same piece of knowledge may take very different forms in them. So I'll stick to the terms source of truth and just some other second database. That's when I talk about do-right problem in general. But not to be too abstract, we'll be mostly looking at the do-right problem in context of data replication to SpiceDB, not just to some other abstract second database. And in these cases, instead of using the term source of truth, I'll be using the term main database, referring to the traditional transactional database where you store most of your data, like Postgres, Dynamo, or Spanner. Because for the purposes of this talk, we'll assume that main database is a source of truth for any replicated piece of data. Yes, theoretically replicating in the other direction is also an option, but we won't consider that. We're replicating from the main database to SpiceDB. So in different contexts, I'll refer to the database on the left side of the giant white replication arrow as either source of truth or main database, or even more specifically, Postgres or Spanner. Please keep this in mind. And finally, don't get confused when I call SpiceDB a database. Maybe I can blame the name. Of course, it's more than just a database. It is a centralized authorization system. But in this talk, we're actually care about the underlying database only. So hopefully that doesn't cause any confusion. All right, we're done with primitive definitions. Now let's define what the do-right problem is. And let's start with an oversimplified but real example from home automation. Let's say there are two types of resources. homes and devices. Users can be members of multiple homes, and they have access to all the devices in their homes. So whether the device is in one home or another, that information obviously has to be stored both in the main database, in this case Spanner, and in SpiceDB. And if you want to move a device from one home to another, now you need to update device's home in both databases. If you get a task to implement that, you would probably start with these two lines of code. You first write to the source of truth, which is Spanner, and then write to the second database, which is SpiceDB. The problem is you cannot write to both data stores in the same transaction because these are literally different systems. So a bunch of things can go wrong. If the first write fails, it's easy. You just let the error propagate to the client and they can retry. But what about the second write? What if that one fails? Do you try to revert the first write and return an error to the client? But what if reverting the first one fails? It's getting complicated. Another idea, maybe open a Spanner transaction and write to SpiceDB with the Spanner transaction open. I won't spend time on exploring this option, but it also doesn't solve anything, and in fact just makes things worse. The truth is, none of the obvious workarounds actually make things better. So we'll use these two simple lines of code as a starting point and just acknowledge that there is a problem for us to solve there. The second write may fail for different reasons. It's either because of a network problem, or a problem with SpiceDB, or even the machine itself terminating after the first line. In all of these scenarios, the two databases become out of sync with each other. One of them will think that the device is in home 1, and another will think that it is in home 2. Second write failing can create two types of data integrity problems. It's either SpiceDB is too restrictive, it doesn't allow access to someone who should have access, which is called false negative on the slides, or the opposite, SpiceDB can be too permissive, allowing access to someone who shouldn't have access. False negatives are more visible. It's more likely you would get a bug report for it from a customer. But false positives are actually more dangerous because that's potentially a security issue. We've already tried several obvious workarounds and none of them worked. But let's give it one last shot. Given that it is false positives that are the main issue here, maybe there is a simple way to get rid of those? Let's try a special write operations ordering. Namely, let's do SpiceDB deletes first, then in the same transaction make all the changes to the main database, and then do SpiceDB upserts. So in our example, device is first removed from home 1 in SpiceDB, and then after the Spanner write, device is added to home 2 in SpiceDB. And it actually does the trick. And it's easy to prove that it works not only in this example, but in general. If there are no negations in the schema, such an ordering of writes ensures no false positives from SpiceDB. So now the dual write problem looks like this. Much better, isn't it? No security issues anymore. Let me play devil's advocate here. If the second or the third write fails, let's say 100 times per month, we would probably hear from nobody, or maybe one user. But for one user, can you fix it manually? But aren't we missing something here? The problem is there is a whole class of issues we've ignored so far. It's race conditions. In this scenario from the slide, we're doing writes in the order that was supposed to totally eliminate the false positives. But as a result of these two requests from Alice and Bob, we get a false positive for Tom. That's because we're no longer talking about failing writes. None of the writes failed in this scenario. It is race conditions that caused the data integrity problem here. So we have identified two causes or two sources of discrepancies between the two databases. The first is failing writes, and the second is race conditions. So unfortunately, yet another workaround doesn't really make much difference. Back to our initial simple starting point, 2 consecutive writes. First write to the main database, and then write to SpiceDB. Probably in a try-catch, like here. And one last note looking at this diagram. Often people think about the dual write problem very simplistically. They think if they can make all the writes eventually succeed, that would solve the problem for them. So all they need is a transactional outbox or CDC, change data capture, or something like this. But that's not exactly the case, because at the very least, there are also race conditions. And as we'll see very soon, it's even more than that. And now let's add backfill to the picture. If you're introducing a new field, a new type of information that you want to be present in multiple databases, you just make the schema changes, implement the dual write logic, and that's it. You can immediately start reading from the new field or a new column in all the databases. But if it's not a new type of information, if there is pre-existing data, then the data needs to be backfilled. Then the new column, field, or relation goes through these 3 phases. You can say there is a life cycle. First, the schema definition changes, new column is created or something like this. Then dual write is enabled. And finally, we do a backfill, which iterates over the existing data and writes it to the second database. And once the backfill is done, the data in the second database is ready to use. It's ready for reads and ready for access checks, if we're talking about SpiceDB. And as it's easy to see from the backfill pseudocode, backfill also contributes to race conditions, simply because the data may change between the read and write operations. And again, welcome false positives. Okay, so far we've done 2 things. We've defined the problem, and we've examined multiple tempting workarounds, just to find that they don't really solve anything. Now let's take a look at several approaches used at Google and Canva that actually do work, and of course discuss their trade-offs. First of all, doing nothing about it is probably not a good idea in most cases, because authorization data integrity is really important. It's not only false negatives, it is false positives as well, which, as we remember, can be a security issue. The good news is there are multiple options to choose from if you want to solve the dual write problem. And let's start with the solution we used in our team at Google, which is pretty simple. We just had a cron sync job. That job would run several times per day and fix all the discrepancies between our spanner instance and Zanzibar. Looking at the code on the right side, because of a sync job, we can keep the dual write code itself very, very simple. It's basically the 2 lines of code we started with. Sync jobs at Google are super common, and what made it even easier for us here is consistent snapshots. We could literally have a snapshot of both Spanner and Zanzibar for exactly the same instant, and then feed it as an input to our MapReduce style sync job, which would sync data for 100 million of users in just a couple of hours. And interestingly, sync jobs is the only solution that truly guarantees eventual consistency, no matter what. Because in addition to write failures and races, there is also a third problem here. It is bugs in the data replication logic. Now, the most interesting part is how did it perform in practice? And thanks to our sync job, we actually know for sure how did it go. Visibility into the data integrity is a huge, huge benefit. We not only knew that all the discrepancies get fixed within several hours, but we also knew how many of them we actually had. And interestingly, the number of discrepancies was really high only when we had bugs in our replication logic. Race conditions and failed writes, they did cause some inconsistencies too, but even at our scale, there was a small number of them, typically tens or hundreds per day. Now, talking about the downsides of this approach, there are 2 main downsides. The first one is there are always some transient discrepancies, which can be there for several hours, because we're not trying to address race conditions or failing race in real time. And the second problem is infra costs. Running a sync job for a large database almost continuously is really, really expensive. All right, we're done with the sync jobs. Now, all the other approaches we'll be looking at, they leverage the transactional outbox pattern. For some of those approaches, you could achieve similar results with CDC, change data capture, instead of the outbox, but outbox is more flexible, so we'll stick to it. And at its core, transactional outbox pattern is really, really simple. When writing changes to the main database, in the same transaction, we also store a message saying, please write something to SpiceDB. And unlike traditional message queues outside of the main database, such approach truly guarantees for us at least once delivery. And then there is a worker running continuously that pulls the messages from the outbox and acts upon them, makes the SpiceDB writes. Note that I mentioned a Z token here in code, but these are orthogonal to our topics, so I'll just skip them on the next slides. As I already mentioned, the problem transactional outbox solves for us is reliable message delivery. Once SpiceDB and network are in a healthy state, all the valid SpiceDB writes will eventually succeed. One less problem for us to worry about. But similar to CDC, it doesn't solve any of the other problems. It obviously doesn't provide any safety nets for the bugs in the data replication logic. And as it's easy to see from these examples, transactional outbox is also subject to race conditions, unless there are some extra properties guaranteed, which we'll talk very, very soon about. Okay, now that we've set the stage with transactional outboxes, let's take a look at several solutions. The second approach to solving the dual write problem is what I would call microsyncs. Not sure if there's a proper term for it, but let me explain what I mean. In many ways, it's very similar to the first approach, cron sync jobs. But instead of doing sync for the whole databases, we would be doing targeted syncs for specific relationships only. For example, if Bob's role in Team X changed, we would completely resync Bob's membership in that team, including all his roles. So in the worker, we would pull the message from the outbox, then read the data from both databases, and fix it in SpiceDB if there are any discrepancies. To make it scale, instead of writing it to SpiceDB from the worker directly, we can pull those messages in batches and just put them into another durable queue, for example, into Amazon SQS. And then we can have as many workers as we need to process those messages. But aren't these microsyncs subject to races themselves? They are. Here on this diagram, you can see an example of such a race condition creating a discrepancy. But adding just a several seconds delay makes such races highly unlikely. And for our own peace of mind, we can even process the same message again, let's say in 1 hour. Then races become practically impossible. I mean, yes, in theory, internet is a weird thing that doesn't make any guarantees, but in practice, even TCP retransmissions, they won't take an hour. So the race conditions are solved with significantly delayed microsyncs, and you can even do multiple syncs for the same message with different delays. Now, what about bugs in the data replication logic? And in practice, that's the only difference with the first approach, is that microsyncs, they do not cover some types of bugs. Specifically, let's say you're introducing a new flow that modifies the source of truth, but then you simply forget to update SpiceDB in that particular flow. Obviously, if there is no message sent, there is no microsync, and there would be a discrepancy. But apart from that, there are no other substantial downsides in microsyncs. They provide you with almost the same set of benefits as normal sync jobs, and even fix discrepancies on average much, much faster, which is pretty exciting. And finally, let's take a look at a couple of options that do not rely on syncs between the databases. Let's introduce a version field for a replicated field. In our home automation example, it would be a home version column in devices table, and a corresponding home version relation in SpiceDB device definition. And then we must ensure that each write to the home ID field in Spanner increments the device home version value. And then in the message itself, we also provide this new version value so that when worker writes to SpiceDB, it can do a conditional write to make sure it doesn't override a new home value with an older one. And there are different options how to implement this, but none of them are really simple. So introducing a bug in the replication logic honestly is pretty easy. And the worst thing is, unlike sync jobs or even microsyncs, this approach doesn't provide you with any safety nets. When you introduce a bug, it won't even make it visible. So yeah, that's the three downsides of this approach. It's complexity, no visibility into the replication consistency, and no safety nets. And the main benefit is it does guarantee there would be no inconsistencies from race conditions or failed writes. And the last option is here more for completeness, to explore the idea that lies on the surface and in fact almost works, but there are a lot of nuances, limitations, and pitfalls to avoid there. And that's the only option where we solve the dual write problem by actually abandoning the dual write logic. So let's say we have a transactional outbox, and the only thing service code does, it writes to the main database and transactional outbox. No SpiceDB write there. So there is no dual write. And there is just a single worker that pulls a single message at a time, the oldest message available in the transactional outbox, and then it attempts to make a SpiceDB write until it succeeds. So the transactional outbox is basically a queue. And that by itself guarantees eventual consistency. I'll give you some time to digest this statement. You can prove that as long as there are no bugs, transactional outbox is a queue, and there is a single consumer, eventual consistency between the main database and SpiceDB is guaranteed, because it's FIFO, first in, first out, and there are no SpiceDB writes from service code. However, a single worker pulling one message at a time from a queue wouldn't provide us with a high throughput. So you might be tempted to, instead of writing to SpiceDB directly from the worker, to put it into another durable queue. But I'm sure you can see the problem with this change, right? We've lost the FIFO property. So now it's subject to races, unless that second queue is FIFO as well, of course. But if it's FIFO, guess what? We're not increasing throughput. So yeah, if we're relying on the FIFO property to address race conditions, there is literally no reason to transfer messages into another durable queue. If you want to increase the throughput, just use bulk SpiceDB writes. But you would need to pre-process them to make sure there are no conflicts within the same batch. Yes, there is no horizontal scalability, but maybe that's not a problem for you. Yet, what would probably be a problem for most use cases is that a single problematic write can stop the whole replication process. And once we actually experienced exactly this issue, a single malformed SpiceDB write halting the whole replication process for us. And that's pretty annoying, as it requires manual intervention and pretty urgent. And yet another class of race conditions is introduced by backfills, because FIFO is the property of the transactional outbox. But backfill writes, fundamentally, they do not go through the outbox. So yeah, while it's possible to introduce a delay to the transactional outbox specifically for the backfill phase to address it, I would say the overall amount of problems with this approach is already pretty catastrophic. So let's do a quick summary. We've explored 4 different approaches to solving the dual write problem, and here is a trade-off table with the pros and cons of each of them. The obvious loser is the last FIFO transactional outbox option, and probably conditional writes with the version field is not the most attractive solution as well, mostly because of its complexity and lack of visibility into the replication consistency. So the 2 options we're probably choosing from is the first and the second one. It's 2 types of syncs, either a classic cron sync job or microsyncs. And yeah, you can totally combine most of these approaches with each other if you want. We're almost done. I just wanted to reiterate on the fact that dual-write is not a SpiceDB problem. It's a data replication problem. So let's say you're doing event-driven replication. Strictly speaking, there are no dual writes, same as in the last FIFO option, but ultimately there are two writes to two different systems, to two different databases. So we're facing exactly the same set of problems. Adding a transactional outbox can kind of ensure all the valid writes will eventually succeed, but probably only if you own the other end of the replication process. Then you can also add the FIFO property to address race conditions, which is option 4. But the first three approaches without Zanzibar or SpiceDB would be really tricky, if not impossible, not only because of the data ownership problem, but also because of aggregates. With event-driven replication, you're probably not replicating simple atomic facts. So yeah, SpiceDB makes the dual-write problem and ultimately the data integrity problem much more manageable. And that's it. Hopefully this small presentation brought some clarity into the highly complex dual-write problem. Thank you for your time, and AuthZed folks, congrats on 5 years. Way to go.
Well, thank you so much for that talk, Artie. I must shout out one thing for Artie, that is. Artie has actually authored a book. It's called Code Health Guardian, and you can find it on Amazon. The subtitle of the book is The Old New Role of a Human Programmer in the AI Era. So Artie, thank you again for the talk about the dual write problem. As Artie mentioned, this dual replication problem, it's not a SpiceDB specific thing. It's something that happens when you have data that's being written to two sources in distributed systems. Now, that might have sounded very complicated, but the next talk is by Joey, our CTO, who's actually going to tell you a very easy way of how you can get data into SpiceDB. So Joey, over to you and your demo.
CTO and co-founder here at AuthZed, and today I'm going to give a brief demo and walkthrough of the in-development SpiceDB Postgres foreign data wrapper proxy. Just for a little bit of background before I get into that, SpiceDB was designed from the ground up to be the single source of truth for authorization, both the relationships that define the access control and the permission checks that enforce it. To support this, it exposes a detailed API available over gRPC and REST, enabling many different applications to integrate with a common authorization source. For large distributed applications, this universal API is very powerful. It allows services built with different languages, frameworks, and database all to collectively talk to the single permissions source of truth. But unfortunately, there are trade-offs. We found that developers need to learn a new API, And for monolithic applications that live entirely in a single relational database, calling out to an external service can feel like an unnecessary hurdle. To address this, we at AuthZed have been developing the SpiceDB Postgres foreign data wrapper proxy, a new way to integrate authorization directly into Postgres and interact with it directly as a result. Just to get started here, let's dive into how the Postgres foreign data wrapper proxy for SpiceDB makes interacting with SpiceDB from Postgres really simple. To get started, I have Postgres running here in one tab. I have SpiceDB running here in another tab. And I have the foreign data wrapper proxy running in a third tab connecting the two. On the Postgres side, I have a simple documents table that contains a document ID, title, and contents. For SpiceDB, I have a simple schema representing a document with two roles, reader and writer, and two permissions, view and edit. Now let's first see how we can interact from Postgres with SpiceDB. We can select star from the schema, virtual table. Immediately we see the schema that was written into SpiceDB, as I just displayed. And we can see here that this is actually being returned as part of a schema text virtual column on the virtual table. One of the really nice things about the Postgres foreign data wrapper proxy is that it is rewriting the SpiceDB API calls and responses into formats that Postgres understand. So from the perspective of Postgres, this is simply yet another table. Similarly, we can select from the relationships virtual table, the relationships that are found in SpiceDB. In this case, I haven't yet written any, so we can see here that there are no quote unquote rows found or no relationships found in the system. As a result of having no relationships, if I select from the permissions virtual table for a particular document and a particular subject, you can see here that user Tom does not have permission for this document for this user. And so all of these calls against these virtual tables are making real calls against SpiceDB. If I were to go over to SpiceDB itself, we can see here the read relationships call, the read schema call, the check permission call. All of these calls are actually being made in real time by the foreign data wrapper as I interact with it from the Postgres side. Now, let's say I wanted to insert some relationship into SpiceDB. Traditionally, this would have to be done via write relationships call. And if you're interacting and writing data to both Postgres and to SpiceDB, you'd have to do them in separate API calls. But with the Postgres foreign data wrapper, all you have to do is insert into the virtual relationships table like you would insert into any other table. So here I can copy these three insert calls, and you can see all three succeeded. And now if I select from the relationship table, all three relationships are present. This is also really nice because you can do these insertions as part of the same insert transaction as data for other tables in Postgres. While Postgres won't ensure that the transactions both succeed because there is not currently two-phase commit within foreign data wrappers, there is some error checking here that will mean that if you try to insert into SpiceDB and it fails, the data will not get inserted into Postgres, which is very nice. Now that I've inserted relationships into SpiceDB, I can select my permission again, and now we can see that has permissions become true because SpiceDB has access to those relationships. Now, while checking permissions for a particular resource and a subject is very useful, there are other API calls and capabilities that SpiceDB provides. Most notably, the lookup methods. Lookup resources, which allows you to ask the system for all of the resources that a particular user has access to. And lookup subjects, which is the inverse, asking for all the subjects that has particular access on a particular resource. Because this is SQL, we can just make slight modifications to the select calls to call those other APIs. To get started, if we drop the resource ID column from the select call and just say resource type and permission, we get a lookup resources call. So here we can see that Tom only has access to view first doc, while Jerry has access to view both documents. Again, this is being translated to a lookup resources call in SpiceDB. And if we go over to SpiceDB output, we can see the two lookup resources calls that were made. Similarly, if we drop the subject ID and leave in the resource ID, then we get a lookup subjects call. So here we're asking for all of the users that have view permission on this first doc. And here we can see it's both Tom and Jerry. And on the SpiceDB side, we can see this is now a lookup subjects call. While all of these calls are really useful and being able to select directly from the permissions virtual table is very important, this capability starts to really shine when we start to do what is known as ACL-aware filtering. So for those who are unaware, one of the hardest problems when interacting with an external authorization source such as SpiceDB is the concept of an ACL-aware filtered index problem. Here, the idea is you want to be able to select specific data from your relational database, say all the documents whose title starts with the letter A, while also being able to say only those documents that a particular user can, say, view or edit. Traditionally, when working with an external authorization system such as SpiceDB, this would be done via what we call pre-filtering or post-filtering. In pre-filtering, you would make a lookup resources call to SpiceDB and get all the IDs of all of the documents that the user can view. And then you would give that set of document IDs to the select query along with the additional filter, and then the SQL database would do the filtering for you. Another option is to select the documents first from the SQL database and then do checks on those documents to ensure that the user has access. While both approaches work, they suffer from the same issue, performance. In one scenario, if your documents on lookup resources, your list is incredibly long, now you're sending a huge number of documents to the SQL database. Likewise, if the filter in the SQL database returns a huge amount of documents, you now have to do a batch check on a huge amount of documents in SpiceDB. Being able to determine whether to do a pre-filter or a post-filter is a hard problem and is very specific to the particular user, the particular resource type, the data shape, etc., of your permission system and your relational database. To solve this problem, the Postgres foreign data wrapper does this kind of join for you automatically. And it does so by simply using an actual SQL join. So for example, if I wanted to select all of those documents in which Jerry has access and then order by the document title descending, all I have to do is use an actual join between the permissions, resource ID, and the document ID, specifying the proper resource type and permission, etc., and execute it. And we'll see here that it returned the two documents that Jerry has access to, ordered by title, and only those documents. Now, while this may seem simple in display, what's actually occurring behind the scenes is incredibly powerful. Postgres is actually asking the foreign data wrapper for statistical information to determine whether it should automatically issue a pre-filter or a post-filter query. And SpiceDB is able to return that information to Postgres to have Postgres select the optimal filter. Furthermore, if Materialize is being used behind the scenes, Materialize has the exact data set count for any permission that's being watched, which further improves the performance of Postgres, allowing Postgres to choose between pre-filtering, post-filtering, or even, in fact, if the numbers are small enough, individualized permission checks where applicable. So overall, we feel that the SpiceDB Postgres foreign data wrapper provides significant developer experience benefit, performance benefit, and other benefits. And we're hoping that you'll be able to try it soon by the end of the year and give us some really great feedback. Thanks, everybody.
I must say that I've met my fair share of people who do code, who are gamers, who work a lot on the internet. But I must say that the person with the fastest typing speed that I've seen is Joey. Joey's probably going to hate me for saying that, but no, seriously. I think the Postgres foreign data wrapper is such a huge game changer. And in fact, I'm just going into the comments, and I think Scott K echoes that as well. Who says this foreign data wrapper proxy is absolutely huge for migrations, amazing. And yes, agree. And we hope to see, or we hope that you will see this in the form of a product by the end of the year. I'll just shout out a couple of other comments. Soumyadeep, thanks for watching. Ashutosh asked, AuthZed Cloud looks interesting. Can I get some credits to try out AuthZed Cloud? And we replied with the link. So if you're just joining us, there is an AuthZed Cloud starter program. So click on that link and apply for cloud credits, and you can get up to a month of AuthZed Cloud credits to try for free. We're super excited. And again, if you missed it, we did launch AuthZed Cloud earlier today. And there was also a question from Casey Lemieux. For AuthZed Cloud, any descriptions on the monthly pricing? Can't seem to find anything about the actual cost besides the fact that it's usage-based. Well, my favorite answer in all of tech is it depends. So AuthZed Cloud is an infrastructure as a service. like AWS. So your billing sort of depends on different dimensions. And as Jimmy, one of our co-founders, said, it depends on things like vCPUs, gigabyte hours, and so on. For production, we'd recommend a config that would come up to about $1,200 per month. But, again, it depends. Keep those. Yeah. Also, Jimmy is saying that Joey is also the loudest typer. Joey, Jimmy's words, not mine. I just think you're the fastest typer. Anyway, we are going to keep this show moving along, and we have Andre from Turo, who is going to talk to us about how Turo uses SpiceDB. We also have Andre for a live Q&A session immediately after this talk. So make sure any questions that you have, put that in the comments. And immediately after this talk, which is about 15 minutes, Andre is going to join me for a live Q&A. So I will see you in.
Hello everyone, and welcome. I'm Andre, a software engineer at Turo, working with SpiceDB for just over 2 years now. I'm here to share a bit of our experience with SpiceDB as a product and AuthZed as a hosting partner. Congratulations, by the way, to AuthZed for its 5-year anniversary. It's a privilege to be celebrating this milestone together. So let's get started. First, a quick introduction to those who don't know Turo. We're the leading car sharing platform in the world, operating in most of the US and 4 other countries. Our mission is to put the world's 1.5 billion cars to better use. Our business model is similar to popular home sharing platforms you may be familiar with a fundamental difference. Vehicles are inexpensive compared to homes, so it's common that hosts build up fleets of vehicles on Turo. In fact, many of our hosts build successful businesses with our help. And therein lies a challenge that we solved with SpiceDB. Hosts have responsibilities, such as communicating with guests in a timely manner, taking pictures of vehicles prior to handoff, and again, upon return of the vehicle to resolve disputes that may happen, managing vehicle schedules, etc. These things take time and effort, and as you scale up your business, fleet owners often hire people to help. And the problem is, in the past, Turo had a flat ownership-based permission model. You could only interact with the vehicles you own. So hosts had no other choice but to share their accounts and their passwords. Safe to say that folks in the target audience of this event understand how big of a problem that can be. Moreover, third-party companies started sprouting all over the place to bridge that gap, to manage teams by way of calling our backend, which adds yet another potential attack vector by curating, Turo's customer data. So it had become a large enough of a risk and a feature gap that we set out to solve that problem. The solution was to augment the flat ownership-based model with a team-based approach, where admin hosts, meaning the fleet owner, can create teams that authorize individual drivers to perform specific actions, read, fine-grained, on one or more of the vehicles that they own. Members are invited to join teams via email, which gives them the opportunity to sign up for a Turo account if they don't yet have one. So the solution, from a technical standpoint, is a graph-based solution that enables our backend to determine very quickly, can driver ABC perform a certain action on vehicle XYZ? In this case right here, can driver ABC communicate with guests that booked that certain vehicle? SpiceDB made it trivial to design and implement the solution compared to traditional relational databases, which is most of our backend. Moreover, it offloaded our monolithic database with a tool that offers a much higher performance and throughput. Anecdotally, the simplicity of SpiceDB helped implement a last-minute requirement that creeped in late in the development cycle. support for inactive team members, the ones who are pending invitation acceptance. Prior to that, the invitation system was purely controlled in MySQL, and we realized, you know what, if we're storing the team in SpiceDB, why not make it so that we can store inactive users too? And the reason I'm mentioning this is this impressed everybody who were working on that feature at the time, because it was literally one single line of code that we had to change in the schema to enable this. It was, I'll talk more about this in a second where I show some technical things, but the graph that I just mentioned then roughly translates to this schema. So this is simplified but still accurate rendition of what our SpiceDB schema looks like. Hopefully clarifies how driver membership propagates to permissions on vehicles, if you're familiar with SpiceDB schemas. Some noteworthy mentions here are self-referencing relations, this guy up here, or all the way up there. So basically this is how we implemented the inactive users. If you notice that there's the member role and then an active member role, and by way of adding a single record that connects the member role with the active member role in the hosting team, you can enable and disable drivers. So this was so incredibly impressive at the time, because we thought, we're gonna have to change the entire schema and a whole bunch of other changes, and no, that's all it took. And again, it's one of those things that once it clicked, if you're familiar with SpiceDB but not with the self-referencing relation, looking at this, that # member role and pointing to a relation in the same definition, it kind of looks a little daunting. It did to me. I don't know, you're probably smarter than I am, but it was daunting. But then one day it just clicked, and I'm like, okay, that's how it is. And I was super stoked to continue working with SpiceDB and implement more and more of the feature, and help the feature team, actually, because it was a separate feature team that was working on this. So that self-referencing was interesting. The other noteworthy mention here is namespaces. If you notice, in front of the definition, there's a hosting teams /. This is how we separate the schema into multiple copies of the same schema in the same cluster. We have a ephemeral test environment in which we create and destroy on command sandbox replicas of our entire backend system. This enables us to deploy dozens, if not hundreds, of isolated copies of the schema along with everything else in our backend to test new features in a controlled environment that we can break, that we can modify as we see fit without affecting customers. And the namespacing feature in SpiceDB allowed us to use the same cluster for all those copies, and save us some money, because we don't have to stand up a new server. There's no computational costs or delays or any of that in provisioning computing resources and this and that. So the feature was released the week of us going the pre-deployment, pre-live, like in a test environment. And we were probably the first adopters of this, and it was really cool. So let me see. At a high level, this is how our hosting team feature works. You can see, let me use the mouse here. You can see how permissions propagate to teams. So team pricing and availability goes to the relation of the team in the hosting team. Hosting team has the pricing and availability for active member roles or admin role. Plus sign, as you all know, is a OR. And then it connects to the driver. Simple, fast. This is blistering fast. One other query that we make to SpiceDB very, very often. Matter of fact, this is the single most issued query to SpiceDB at any given time is the currently logged in user a co-host? And that's done for everybody, even if you're not a co-host. This is how we determine whether you're a co-host or not. That will then drive UI, decisions, what widgets to show, only if it's pertinent to you, if you're a co-host. If not, then there's no reason to pollute the UI with co-hosting features. Yeah, and this is what the UI looks like. So you on a team, you have co-hosts, and you can add or invite. Here's an interesting thing. The code name of the project was co-hosting. It ended up being hosting teams because we then used the nomenclature co-host to add people to teams. So here you have your co-hosts. You can invite them by email. They get an email that points them to sign up to Turo. If they already have an account, they can just log in. And the moment they log in, it automatically accepts the invitation. Next, you have the fine-grained permissions of what your group can or your team can do. In this case, we have trip management enabled. This is the base, actually. The base permission that you have to grant to everybody on the team. And then there's pricing and availability that allows you to set prices for vehicles, discounts, see finances and all that stuff. So you can imagine why that's why it's very nice to be able to toggle this and not let just any co-host that has no business looking at your finances, just hiding it from them by way of untoggling the permission here. And then you have your vehicles. The list shows all the vehicles you own. You just toggle the ones you want, save, and you're off to the races. Your hosting team is in place and working. So, AuthZed as a hosting partner. When you're considering using, a big challenge of adopting a new system is setting it up and running it in a scalable and reliable way. You have to manage, security issues. You have to manage auto scaling. You have to manage all kinds of, infrastructure challenges. And that costs money. In this day and age, it's really hard to find engineers who understand infrastructure well enough to manage all the moving parts of a highly scalable system such as SpiceDB. For over 2 years, Turo has used AuthZed's fully hosted cloud offering, where they're responsible for deploying and maintaining all the infrastructure required by the SpiceDB clusters. And that gives us time back to focus on growing our business, which is our primary concern. So this is a great opportunity actually to give AuthZed a shout out for their excellent reliability. In over 2 years, 2 years and 3 months now actually, of operations in production, we had a single incident. And even then, in that event, they demonstrated the capacity to recover from faults very, very quickly, to pinpoint the problem incredibly quickly and, take care of it. I think the outage was, we were out for like 38 minutes, something like that. It was, we've had other partners that things were much, much more challenging. So, and once in 2 years, the root cause, the entire handling of the outage was very, very, nice to see, because it involved thorough analysis, postmortems, and making sure that it doesn't happen again, putting in safeguards to ensure that it doesn't happen again. So everything was systems fail. We understand that, and how we deal with it is what shows how how good you are. And with AuthZed, we rest, easy knowing that we're well taken care of. And ultimately, hosting with AuthZed saved us money in the long run, because it would otherwise take a lot of engineering time and effort just to keep the clusters running. So if your company is considering adopting SpiceDB, I would highly encourage you to have a chat with AuthZed about hosting as well. From our experience, it's well worth the investment. And lastly, on behalf of Turo, I'd like to thank folks who were instrumental in the success of this project. John and Lee and Evan Corcoran, who are pretty much our first points of contact and for always helping facilitate things for us. Jimmy Zelinskie, Joey Schorr, and Jake Moshenko, who helped us get up to speed in the initial states of the project 2 years back. Evan, Cordell, and Kyle B as first responders to our requests and the one incident, and everybody at AuthZed for being great, for doing great things, for helping us so much, and for the opportunity to for me to speak here to you all today. And here's to the next 5 successful years. Cheers, folks.
Hello, and we have the man of the hour, Andre. Andre, first off, that was an amazing talk. Thank you so much. I think it was so cool, just like hearing you speak about how you all built it, and it came across as like, super informative and friendly as well. So yeah, congrats on that talk, and thanks for joining us for this live Q&A.
Yep, you're welcome. Thanks for having me.
Yeah. I must ask, though, what did you use to make the slides with like the green screen and like the slides behind you? I think I need to take some notes from you on that.
It was a concoction of OBS Studio, some chroma key filters, but I don't have a green screen behind me, so I actually used the MacBook background feature on the camera plus a pure green image background that I downloaded off of the internet and set it as the background on the camera, so that it simulates a green screen. It was a mess. I'm glad it worked out, but yeah,
it 100% worked. I mean, it looked great. There were a couple of chats in our internal Slack as well saying, "Oh, the slides look very nice." So yeah, it definitely did. Andre, so we have a couple of questions in the chat and also from the team. So I'll ask you the first question, right? Yeah, even Scott says the green screen process is genius. Yeah, you got to like blog about this. That's super nice. Yeah. So first question, Andre, is how did you come across SpiceDB and AuthZed?
So we did a lot of investigation on overhauling our authentication and authorization stack at Turo. Not to get too much into detail, but in the last several years, Turo has focused a lot on breaking up the monolith application that we have into smaller, more manageable pieces, sometimes using custom microservices that we write, and sometimes buying versus building. And then for every such project, we look into those alternatives. First question we ask is build versus buy. And then we looked into solutions online, came across the Google Zanzibar spec, and then we looked into alternatives. If I'm being honest, we came across SpiceDB by way of another vendor that at the time offered an entire suite of authentication solutions, including an API gateway and an authentication OAuth 2 server, plus a Zanzibar-based model. But we felt that we would be too locked into their ecosystem at the time. We only really needed the authorization side of things, and only for a small subset of features in our application, which is co-hosting or hosting teams. We felt that getting into that ecosystem would kind of lock us in and kind of pull us in forcibly. And we, among all the candidates, we found that SpiceDB was the best candidate. We felt that the solution was, simple enough, easy enough. Support was tremendous. At the time, I'll be honest, what really swayed my decision was the playground. We loved that feature. It has since been decommissioned, but the fact that you could just hop in and try it out right then and there on your browser. Oh, it's still there.
It's still there. It's still there. It's not decommissioned.
Oh, I'm sorry.
No.
My bad, everybody. I'm spreading misinformation here. Apparently, the playground is there, and it's absolutely genius. So, in the end of the day, the fact that we could test it in real time, because I'll be honest with you, for most folks here must be feel the same way I do. Coming across Zanzibar, the model itself, understanding how it works, how to define those, because ultimately it's a graph database, defining the nodes in the graph, and then setting up the vertices, which are the actual records of data that you add into the database. It can be daunting at first. Having the ability to try it out in real time, it was a game changer, and it really set AuthZed apart from every other competitor. So that's how we came across it. It was a series of hops, and we just absolutely were taken taken aback by the playground, and after talking with that invited a conversation with SpiceDB folks, and once we spoke with you guys, we were sold pretty much.
That's awesome. Andre, on a side note, I think you gave a couple of people mini heart attacks with the playground things.
I am so sorry.
It's good to it's good to keep people on their toes, right? Yeah.
Yeah, I did hear at some point that the playground might have been decommissioned or something. I'm just I am so sorry. That's not what I meant.
No, all good, all good. We do have a question from Veronica, who asks, what surprised or delighted you about either AuthZed, SpiceDB, or even Zanzibar, and other things that you find challenging? Because of course, there could be a learning curve from not doing authorization or doing like a custom implementation of authorization.
Yeah. So the primary thing that impressed us and delighted us was the simplicity, like defining the I call them nodes, but the definitions, right? Like in your the schema, it's just so easy. Like, for example, our driver has nothing in it. It just has to exist there, just so you can actually connect the other definitions into it, all the other nodes with vertices. And then as I started playing more with it, I created a proof of concept of the feature purely in SpiceDB using the ZCLI at a later stage, not just with the playground. But it was just very easy to implement things and to make changes and see the results of what you're working on, which in normal the traditional way that we work, it would take far longer, and it would take a lot more effort, pollute our code with a whole bunch of Spring-based stuff. I'm not going to get into those details, but with SpiceDB, everything was just so easy. But that is to say, what did I find challenging? Understanding the graph-based model. So it really, at first, it's really hard, and to this day, it remains the most difficult part of advocating for the usage of SpiceDB in the company, because most folks are used to the relational model, and when you try to explain the graph model, granted, even to me, there's certain things that are still difficult to grasp and explain. So it still is the hardest part, but once you understand the graph model, then it's everything just turns way simpler and easier to do. So
yeah, I can echo that sentiment, because I think it's so different, basically, right? So there is a bit of a learning curve to understand this thing. And then, of course, everything sort of falls into place, like you said. I think we have time for a couple of questions, and I'll take one from Jimmy, who's also #1 in the YouTube chat right now. Way to go, Jimmy. And Jimmy says, being a platform team member, how do you approach engaging the application teams to make them successful?
So for this specific feature, we collaborated very, very closely. What happened was they were focusing on the feature itself, whereas I was working on operationalizing the usage of SpiceDB. So client libraries, for example, I focused on the client libraries, and they basically told me, this is what we need. And I got back to them saying, this is what I can do. And it was sort of a low-key gentleman's agreement on the contract between the feature code and the library code, and it worked out great. But
nice.
it did require a lot of working together, Zoom sessions. This is like when the pandemic was at the tail end, so we were still working from home, and it required a lot of Zoom sessions. But the result was fantastic. So
awesome. All right, and one final question from me, which is, how do you go about testing SpiceDB in terms of like scale and permissions and relations and things like that? Do you have like a process? Because developers ask me that question, like if how do people at scale do it? So I'd love to hear from you.
So we approached our production testing in a more laissez-faire way. So the client code that I wrote at the time, we rolled out, we did a soft launch of the feature in production with the UI hidden. Actually, the UI wasn't even there yet, but for all the more traffic intensive calls, I added the call to SpiceDB right in and there, and I put I made the call in a separate thread so it wouldn't affect the response times for our customers, and I instrumented the heck out of our code. We have so many internal dashboards and metrics to watch, but basically, for every request that I knew that were traffic intensive, that we get so many calls of, I spawned a separate thread to make the call, and then I measured how many calls we're making, how long it's taking, potential errors. I put a catch-all, like try catch that would ignore the error. So again, to avoid disrupting the application and the user perceived performance, but basically, because we were starting anew with a service that we weren't entirely familiar with in production, I actually opened the floodgates, but in a controlled manner. If it failed, the application would tell us that it's failing, but the user would be none the wiser. That was my approach.
That is super smart. And again, I think I'd love to maybe pick your brains on this after the session. Andre, that's unfortunately all we had time for, but thank you both for the session, for all the nice things you said, and also for this live Q&A. And here's to continued partnership with Turo. Thanks so much. And all the other Turo folks that are watching, thank you all as well.
Thank you all. Thanks for having me over, and happy anniversary.
Thank you. All right, folks, we're going to keep this train running. So do stick around. We have a session from one of our engineers, Victor, who's going to talk about Materialize. We have a surprise guest appearance by Jake, our CEO, to talk about something huge, after which Jimmy will talk to Andy Pavlo, who is the OG of databases, who's professor of databaseology at Carnegie Mellon. So all of that is coming up. So stay tuned, and I will see you.
Hey everyone, welcome to this quick walkthrough of AuthZed Materialize, a feature of AuthZed Cloud that enables near real-time, consistent materialized views of your SpiceDB permissions. I'm Victor, a software engineer here at AuthZed. AuthZed Materialize is inspired by Google's Leopard indexing system described in the Zanzibar paper and built on top of SpiceDB. Instead of evaluating permission checks on demand, it precomputes those results ahead of time and delivers them either via accelerated SpiceDB queries or through streaming interfaces for your downstream data systems. So why is this useful? Two big reasons. One, acceleration. It speeds up SpiceDB APIs, avoiding expensive computations across deeply nested hierarchies or wide relations. And two, authorization-aware UIs. It enables your team to build responsive UIs and APIs by natively featuring data in databases like Postgres or Elasticsearch, so users or robots only see what they're allowed to. In short, Materialize does the heavy lifting upfront, pre-computing how permissions evolve, so SpiceDB gets faster and computer permissions move closer to where your application data lives. In this demo, we'll show what Materialize looks like in the AuthZed Cloud Console, the main APIs, and a hands-on demo building a local index store in DocDB. Ready to go? Start. For simplicity, let's use a trimmed-down version of GitHub's classic role-based access control model with three possible options: reader, writer, and admin. We'll use this SpiceDB schema to illustrate how Materialize works. This is the AuthZed management console. I'm running a development permission system deployment. Alongside, I've created a Materialize deployment that watches the three permissions defined in our demo schema. We can see the current materialization lag, the permissions that this deployment watches, and information about the snapshot it's built from. Let's now switch to the terminal. I've granted myself access to a collection of AuthZed open source repositories, here depicted with SpiceDB relationships. I'm a reader of the AuthZed client libraries and a writer of the AuthZed and SpiceDB repositories. This is reflected in the computer permissions. Materialize exposes two main operations: lookup permission sets and watch permission sets. Lookup permission sets is similar to SpiceDB lookup permissions, but for pre-computed permissions. Results are represented as a compressed form that we call permission sets, which solves the explosion in computer permissions that happen. For example, when a team with thousands of members is granted access to a repository, instead of thousands of events, you get just one. I'm sure some of you have seen this during a reorg at a mid to large size company. Watch permission sets, on the other hand, is equivalent to SpiceDB's Watch API, but for computer permissions. This API streams permission updates as Materialize computes them. Right now there's nothing happening in this deployment. So if I start a small workload that constantly grants and revokes my admin access, watch permission sets will emit the corresponding events, adding and removing me as a member of the repository, reader, and admin sets. There you go. All right. Let's talk about using Materialize in practice. AuthZed customers typically enable Materialize to bring computer permissions closer to their application data, for example, to filter and paginate long lists of resources. They do this by storing a copy of the Materialize view in their database using lookup permission sets and then keeping it up to date using watch permission sets. We'll use the AuthZed's Materialize CLI tool to create and update a copy of our Materialize view in DocDB, a popular OLAP database. First, let's create the initial index in DocDB. DocDB now contains two tables, member to set and set to set. Member to set, my user belongs to the set representing the reader, writer, and admin roles. Under the hood, this data was inserted by storing the results of lookup permission sets. Now, if If I change my permission grants with the set CLI, DuckDB will be updated within seconds. I'll do that by starting the Materialize CLI in update mode. Make sure that I am not running DuckDB right now because it doesn't like multiple readers and writers at the same time. Update is happening now, and I'm gonna add myself as an admin using the set relationships touch. You should see now this flowing via the SpiceDB Watch API here depicted, and we also receive the events using watch permission sets as here depicted. If I now stop the update flow and open my DuckDB database, we should see that now I am shown as an admin. Cool. With the permission set stored in your database, you can now perform the same computation the SpiceDB API provides. For example, you can run check permissions or lookup resources style queries by doing a simple SQL join. So I'm going to be using the Materialize CLI again here to list the repositories where I have admin access by running a simple SQL join in DuckDB. Here I just did a lookup resources asking for view permissions, but if I change it now to admin, it should reflect the right values. Here you go. I'm only admin of the SpiceDB repository. So that's the demo for today. And before wrapping up, let me introduce Materialize's new download permission sets API. This is similar to lookup permission sets, but instead returns download links to Apache Abro files containing permission sets. It's especially useful for data integration and analytics workflows, such as loading permissions into data warehouses, incorporating permissions into data lakehouses for long-term storage and machine learning engineering, streaming into real-time analytics pipeline, or exposing permissions to business intelligence tools. So check it out. And that's it for today demo. Thank you so much, and let's see you next time.
Hello. Oh, I've stopped the music. There we go. Okay, so folks, we just saw a great demo from one of our engineers, Victor, about AuthZed Materialize. This particular segment, though, wasn't on our original schedule, but Jake and I were like, hey, it's been an hour and a half and we haven't spoken about AI, so, we got to fix that. And Jake has some big news for us. Jake, why don't you take it away?
Yeah, I'm excited to finally be able to share all of the work that we've been doing together with OpenAI. We just got through the final hurdles to be able to share this information with you all. But we're actually we're the technology behind OpenAI's data connectors ability, where OpenAI can connect up to like your corporate Google Drive or your SharePoint or things like that. They've ingested and set permissions. So you can see the number right there, over 37 billion documents using this technology. So a true testament to the scalability and the flexibility of AuthZed and SpiceDB. And I'm just, we've been working with them. They're such a great team, such an amazing team. We've been working with them for quite some time now. But, as most companies are, they're very cautious and judicious with the use of their brand. And so they wanted to make sure things were really living up to their standards and really working well before we could share this news with everybody. And that finally happened today, of all days, on our 5th birthday. I can't believe it.
I mean, I think it would have been hard for us to like plan it out. It just like all the pieces aligned. And I think it's big news for us, but also I think it signals a sort of direction of the large AI companies also looking at authorization.
Yeah, I think I also heard we're about to cross, or maybe already have crossed 6,000 stars on GitHub for SpiceDB. So it's the universe is coming together today to tell everybody that this is how they should be doing authorization.
Yeah, and if you haven't starred the SpiceDB repo on GitHub, please do it. We'd love to get to the 6,000 mark before the end of today to celebrate our 5th birthday. It would be such a great birthday gift for us as we are turning 5. Jake, last words about OpenAI and authorization and AI in general?
I mean, if you listen to me, I've written about this many times in the past and talked about this in the past, but like I'm somewhere in between like the true believer that AI is going to change everything and like it's not quite here yet. I don't think it's going anywhere. I think it's here to stay. And the work that we're doing with OpenAI around RAG, like we're doing that same work with other customers. So this is sort of a well-trod path. But I'm very interested to see where our work with agents takes us. I think that's sort of the next big shift, the next big tectonic shift in the way everybody is using and deploying AI. And I think AuthZed has a really interesting story to tell there. And I think we'll hear a little bit more about that later in the stream. But yeah, I think agents is the area to keep your eye on. But if you're currently doing RAG and you want to be able to filter down what your model has access to, you should give us a call because we're doing that quite successfully with a number of customers.
Yeah, absolutely. Do check out more details on the link that you can see at the bottom. That's authzed.com/customer/OpenAI. Well, Jake, thank you so much for both the keynote and this piece of news. But speaking of AI and authorization, we have a very special segment. So we actually got Andy Pavlo, who's the professor at Carnegie Mellon University, and he'll be talking to Jimmy, our co-founder and CPO, about the intersection of AI authorization and databases. So I'm going to bring them on stage right now. Jimmy, Andy, welcome. Thank you for joining us, and the floor is yours.
Hey, can you hear me? How are you guys doing?
Sounds good to me.
Good to see you, Jimmy.
Sohan. Hey, everyone. I'm Jimmy Zelinskie. I'm, as Sohan just said, co-founder and CPO of AuthZed. Today, I'm going to be kicking off our fireside chat, and I'm super excited that Andy is going to be here joining us. If you have ever dipped your toes into the database world, you've probably run across Andy's work, or more likely, his opinions. Andy is an associate professor at CMU, where he runs the database group, and much of what Andy does is actually published online totally for free for anyone to learn from. Whenever I find myself doubting my understanding of something in the world of databases, I'm normally cracking open YouTube and skipping to some portion of a lecture that Andy has generously published online. But today, I wanted to just talk about a variety of subjects with you, Andy, databases, SQL, SpiceDB, and AI, all across the board. But I think it makes the most sense to start with one of your more recent publications. What goes around comes around and around. So this was published in SIGMOD in 2024. And what I really like
SIGMOD record, be very clear.
SIGMOD record, okay.
Yes.
I actually don't know the difference between those.
SIGMOD is for research papers. SIGMOD record is like, I mean, kind of research paper, almost like letters to the editor kind of thing.
Gotcha. Yeah. Maybe that's because of the exact same reason why I prefer this paper to a lot of other types of research. Really, this one is interesting to me because it's almost a reflection on industry. And as a practitioner and someone that isn't just spending my time kind of doing research, but actually applying a lot of research in distributed systems or databases, this type of paper actually really appeals to me because it's directly kind of spoken to me as the practicing engineer. Do you want to give us like a high level overview of kind of what kicked off your reason for writing this paper, why you felt like it had to be written, and kind of the subjects you tackle in it?
Absolutely, but I would say actually SpiceDB powering OpenAI is probably way more interesting than me talking, but we can come to that later. Yeah, so this paper came out, as you said, in 2024. We actually started writing it I think in 2022. And I guess the background history also as well is I wrote it with one of my advisors, Mike Stonebreaker, who, if your audience doesn't know, he won the Turing Award in databases in 2014. He invented Postgres, Ingress, Vertica, a bunch of systems. So he's very prolific in databases. And he actually wrote a earlier version of the paper, What Goes Around Comes Around, in 2005 with Joe Hellerstein at Berkeley. And that paper was a sort of recounting the history of data models in databases. So a data model is sort of a high-level representation of data. As you can think of like tables, that'd be a relational model, or like documents in a JSON database. The document model is the model. And so he went through sort of the history going back to the 1960s of all the things people have tried, but before Ted Codd invented the relational model in 1969, 1970, and then what came after to try to claims that they had better versions of it, right? And it was just, he wrote it just when XML databases were becoming a thing. And the main takeaway from all that was, from that original paper was, every so often people come around and say, hey, the relational model is wrong, is stupid, is not the right way to build a database system and represent data. Here's a better version. And then everyone gets all excited when that new thing comes out. But then it turns out a lot of the things that this whatever new data model was promising and how it was going to solve all the world's problems turned out not to be the case. And everyone sort of comes back to, oh yeah, the relational model is a good idea. An extension of this would add SQL, right? Because SQL, for better or worse, is the primary query language on relational model databases. It isn't the only one. There was other inventions at the time, but SQL is the one that sort of has persisted over the years. And so our follow-up paper in 2024 is the next iteration, 20 years later, looking back of what happened since he wrote that original paper. And it's sort of broken up into two parts. We go through the history of the data models, and then we also go through sort of the major enhancements or major advancements that have come about in the actual implementation of database systems. And without going through every single one, because it's hard to show what I mean by different data models without slides or a whiteboard, the gist of it is like this: people are making the same arguments in the last 20 years that they made 40 years ago about why the relational model and why SQL was stupid. Just look at the document model, the JSON databases, like from the Mongos, the NoSQL guys, and so forth. They were saying, oh, joins are slow, joins are stupid. You want to store everything as JSON. That's way better to pre-join things. And then it turns out that a lot of the arguments they were making were just repeats of stuff that people have figured out were incorrect 20 years prior. And so we just went through and said, here's why, here's why this is incorrect, and here's how the industry is sort of shifted back into SQL is a good idea, and SQL and the relational model is a good idea. Now, so the SQL isn't a perfect query language, but I would say one thing that it has done is that, even though it's from the 1970s and it has certainly some scary corners and some warts to it, it's not a dead language, and the standard keeps getting updated, new features are coming out, and a lot of the things that people would claim, like with these new data models over the last 20 years, oh, SQL relational model stupid, SQL stupid, here's a new thing that's better. It ends up those things get added and absorbed into SQL. So SQL has not stayed stagnant over the past 20 years. It's added new features, it's added support for JSON, it's added support for now graph queries in the latest update in 2024, right? So it has evolved over time to keep up with the changes and trends in how people build applications and want to use data. And I just foresee the next 20 years is going to be the same thing. Right now, SQL is hot. Everyone agrees that SQL is a good idea, but I know there's going to be something in 5 years. I just don't know what it is yet about why SQL is stupid and you can do something else. I mean, the vector database guys kind of treaded in a little bit of this. They're not as strident and vindictive against SQL the way that NoSQL guys were, but I there'll be something else. I just don't know what it is yet.
Yeah, I think it's a really interesting transition. I mean, we definitely saw vector databases emerge kind of as this, I guess, more recent trend in the space. But it was really quickly that we started to see the relational databases kind of consolidate and say, we're just going to add a new index type for this, right? Do you see that being kind of the end all be all for kind of like that RAG kind of data model? Do we think that the existing kind of implementations of these vector indexes are good enough in combination with the relational model backing it? Or do you think there's something to kind of like that inner core of the different vector databases that are kind of dedicated to that task?
So this is the beauty of the, of having a separation between the logical layer and the physical layer of your data. So at the end of the day, a vector is just an array or a list of numbers. And you can represent that, it has a single logical representation. Here's my list of numbers, right? Everyone can understand that. But the way you actually want to physically store it or physically index it, that can be independent of of how the application views the data. So do I think the current vector indexes are end all to be all or sufficient, like HNSW and the other things that are out there? No. And these things will get better over time. But because you have the separation between the logical layer and the physical layer through something like SQL, where you can, you can rewrite and change the implementation of the index without rewriting your application code. Like that's what that it seems obvious now, but back in 1970 when Ted Codd invented the relational model, that was a game changer. So I think when I look at the vector indexes, the vector databases that are out there now, I think they're going to be at the forefront of the index implementations and sort of providing additional operators and functionality on top of it. But I suspect that 99% of the applications out there could probably be handled by like a PG vector or something like that in the other databases out there that have vector indexes.
Yeah, it's super interesting. Right before the OpenAI announcement, we actually gave a demo of something that we built, which was a foreign data wrapper for Postgres that talks to the SpiceDB API. So we're actually giving people kind of virtual tables and the ability to speak SQL to kind of query our backend. How do you feel about kind of the level of integration? You're talking a lot about how like SQL is kind of the lingua franca and we can kind of innovate behind it. Does it matter how it's being kind of built behind it, whether it's kind of foreign data wrapper or built as a native kind of Postgres extension?
But even if it's a native Postgres extension, just using Postgres as an example, right? It has to call out to an outside system to get the data and bring it in, whether it's a foreign data wrapper or written as an extension, I would say I don't think it matters, right? And certainly if it's just retrieving data and not doing heavy computation, the round trip latency of sending the data will be the larger bottleneck. So I think what has actually been pretty cool in the last 10 years, if not maybe a little bit longer, is the composability and interoperability between other database systems. And you sort of saw that at the very beginning with like when Parquet came out and Oracle and these other file formats. Like, hey, I can have one application or one system generate these files, and then I can have another system consume them and read them and process them. That was a great idea, and that has opened up a lot of opportunities for other things. And so now you're starting to see this kind of interoperability in other ways. And kind of Arrow is the medium or the encoding scheme that you'd use to pass this data between different systems. So that part is like super cool. And look, something like DuckDB, you pretty much point it at any file or any HTTP endpoint, it just sucks it in and reads it. So like I think that's like people should not how do I say this? People should not underappreciate how actually game changing that was. Just go back like 20, 30 years, everything had to be like Corba or SOAP, and it was a total nightmare. So yeah, being able to get data in and out from different systems is fantastic. Data Fusion is another one of these systems that are really good at this as well.
Yeah, y'all have a couple projects in that space as well, right? Your students are kind of working on Data Fusion and building things on top of Data Fusion, right?
We are pursuing to build or trying to build a new query optimizer, and it's not something that relates calcite, and so it's not something I want to. We're pitching is this is the query optimizer for Data Fusion, but we are using Data Fusion because there's parts of the system you don't have to build, right? You saw this in the SpiceDB. You don't want to build your own SQL parser. You want to use something that already exists. So So we're just trying to use parts that are already there to speed up and focus on the more interesting core contributions.
Yeah, I think you raise an interesting point because actually we're investing a lot in kind of rethinking how we're doing our own kind of optimization layer and query parsing right now, just internally as an upcoming project for SpiceDB. But we kind of don't traditionally implement SQL. SpiceDB is a little bit different in that sense. So I'm going to be a little bit contentious with you right now, even though I did just talk about how we have this Postgres FTW for folks that do want to use SQL with it. But I remember like the first time we met actually was sending emails to you, and we were trying to convince you to let us do your kind of vaccination talk series during the pandemic.
Yes.
And I remember like the initial outreach was like, hey, like we're building this thing, SpiceDB. It'd be cool if we could present it. And you kind of got back to us and you're like, I don't really think you're a database. And I kind of had to make this argument. I was like, hey, actually, like SpiceDB's architecture still is kind of a database, although it is a domain-specific one. And I think the thing that y'all really kind of got caught up on is we have this storage interface where we can actually plug ourselves into other databases rather than just like a key value store that's persistent to disk. Did I effectively convince you that that is like a reasonable abstraction, or that you can still be a database if you have that model? Like, yeah, what's your reaction to that now? It's been a little bit.
I have to go. So this was 3 or 4 years ago, right?
Yeah.
If I remember correctly, I was being pedantic and not that I was just discounting or saying that you weren't a database, but maybe I was saying you weren't a database system. And so I would say, yeah, I would have to remember exactly what I said. And I think when I remember correctly, when I read the Zanzibar paper that you pointed us at, I was like, okay, it seems permissions, but it's not really storing data. But I guess metadata is data. Like, I mean, you guys gave a talk. I think Josh gave a talk. It was fantastic, so it was fine. No, there's an interesting question.
Jake, our co-founder.
It was Jake. Yeah. Yes.
It's really confusing. We're all 3 J's. There's 3 co-founders. Yes. It's all J.
So I would say there's an interesting question of like how far you can get built on top of an existing system, and what are the sort of trade-offs you make in this. Now, you guys are building sort of a larger distributed system on top of which could be another distributed system as well. And that design idea is not new. A bunch of systems already do that. But I'm, from a research perspective, I'm interested in like how much are you sacrificing by not writing everything from scratch. Now, for your cases, you guys, you care about performance, but at the end of the day, it's the permission service that matters the most. So it's not like you're trying to cram as many transactions per second as you can get. There's an interesting research question to look at, like, if you use an embedded storage manager, what do you gain? What do you lose? I mean, you obviously gain engineering velocity, but what do you lose in that? And then if you build it going up from that, if you build an even larger system on top of, what you guys have done, on top of like distributed system, what do you gain or lose? So yeah, no, I don't think I was that contentious. I mean, I think you emailed me in the middle of the semester. Yeah. You also emailed me in the middle of the semester, so we couldn't add you maybe to the calendar at that time, but we definitely had you pretty early on. No, I liked your talk. I liked the SpiceDB talk because it's not something we normally see. Like here's how to run Postgres transactions faster, or here's how to run OLAP queries faster. So yeah, I like things that are different. So hopefully I didn't give the impression that I was like too negative.
No. You did mention one thing just now, which is another kind of unique aspect of SpiceDB. We kind of default to strict serializability rather than kind of your traditional RDBMS today that kind of has the different isolation layers, probably defaults to something like read committed or even read uncommitted. And then kind of queries layer on kind of the SQL to say how consistent they want the request to be. We kind of default to kind of the maximal consistency and then let you relax it to get performance, and we've kind of taken the opposite posture, right? Have you had any time to kind of like think about that? Because we did present that in the talk and kind of the trade-offs associated with that.
Yeah, so I remember at the time when you guys presented this, it was fascinating because you were one of maybe 3 or 4 applications or users of a system where it was obvious to me why you'd want strict serializability. I'm assuming your audience is technical enough. We don't need to go explain it. As like
they can always look it up in our docs.
Yeah. Sorry. Yeah. As an academic, I always feel like I make sure to define terms before I use them. Obviously the biggest one out there was the AdWords product at Google. It's part of the reason why they made standard support strict serializability. I've only seen it in a small number of cases, and it's usually related to financial stuff. So the fact that like SpiceDB was doing strict serializability, I haven't looked at your codes. I don't know if it's actually correct. I mean,
we end up having to build pretty sophisticated tests to try to prove that what we're actually seeing is strict serializability, it's no.
Are you Jepson certified?
We're not. We should still reach out to them. I have an email chain kind of open with him right now, but we haven't pursued that quite yet. Because another aspect to it is because we support like the different pluggable database backends, we have to force this type of consistency model out of these database systems that maybe weren't designed for it. Like notoriously, like Postgres doesn't support this, but I actually gave a talk at PG Day Chicago earlier this year talking about how we are actually kind of looking into, we're using PG Exact, which is kind of their way to introspect the transactions in flight to actually kind of figure out what things have been fully committed or not. And then we actually also like tail the wall itself, because on Postgres, that's a single instance. Like you do totally serialize down to one point in time. It's just when you append to the wall. So there is kind of like a strict ordering you ultimately get if you can dive deep enough into the transaction system. So that's like a really interesting thing. And then you also know that like Cockroach doesn't actually give you strict serializability. It gives you no stale reads. So we also have lots of tests around our strategies there. And we're working with that team to make sure the way we force transactions to overlap to create a total ordering is being maintained as the way we've implemented it. So it is super interesting, but it varies across the different data stores.
Can you share what OpenAI is using as the backing data store for SpiceDB?
Yeah, it's CockroachDB.
Okay, all right. So,
yeah, we open source users are primarily using our Postgres, but we are primarily using CockroachDB as the backend for AuthZed Cloud, largely because it gives us a good one cohesive story. And if folks want to expand across like different geos, or they have different disaster recovery requirements, we don't have to figure out how to game that out for a million different backends that we support in SpiceDB. But by and large, the open source users are pretty much consolidated on Postgres. So, and it makes sense. Open source versus kind of whatever Cockroach's current license is.
Well, so the lift of getting up Postgres running is much lower than Cockroach.
Yeah, you bet. But long-term maintenance for Cockroach, scaling the horizontal scalability of the system is a very, very nice property. Yeah.
Yes.
Cool. Yeah. So one of the other things you mentioned in your paper, and this really stands out to me, at the core of SpiceDB, we kind of use this graph-like model. And you talk about, as opposed to the relational model, kind of these graph models. The paper really just talks about how there's kind of this optimization problem where graphs are trying to work around long chains of what are effectively joins in a relational database. Do you think that there's been a long time that we've had graph databases? There's been a long time that we've had the relational model. Do you think that there is a future where RDBMSs can handle these long chain joins? Yeah, because we haven't seen it so far.
Yeah, so I mean, let's talk about this. Like the kind of thing, maybe the most simplest graph query you could want to run. Again, ignoring what the data model is, just find all my neighbors, right? And as you said, it's a bunch of series of self joins on the data. So what the graph databases provide you, and using languages like Cypher and the other ones that are out there, is that they're allowing you to do these traversals without having to go back to the client and say, what do I do next? Right. Whereas if in a sort of traditional SQL database, you may have to do a bunch of self joins, but you may have to go back to the client, and then the client then issues the next query to say what the next hop to jump to is. right? And so that back and forth in a relational SQL database would be obviously going to be much slower than like a one-shot, give me this traversal and give me back the results. So what the SQL standard has put out in 2024, maybe in 2023, the latest version, is property graph queries. And this is something that was spearheaded by Oracle and others. And it takes a lot of inspiration in the GQL standard that's being trying to push by a bunch of the graph database people as well. And that allows you now to specify in SQL these graph traversals as a sort of one-shot SQL query without having to go back to the client and do initial processing. And you can sort of fake this without the SQL extension using UDFs or having a middleware do it for you. There's a front end for Postgres called HDB. Maybe that's a commercial product, but basically it's a graph interface on top of Postgres. But the basic idea is still the same. Like you do all the traversal on the server and not have to go back to the client. All right. So now that you can specify the query in such a way that you can do the traversal without having to go back to the client, and the next question is the relational model the right data model to represent to represent the graph data? And I would argue yes, for two reasons. One is, there's been so many advancements in the last the last 20 years on encoding schemes and compression schemes for storing large amounts of data in a columnar format and be able to process it really efficiently using vectorized execution, where you're sort of looking at batches of records rather than one at a time. If you're sort of chasing pointers in the way sort of Neo4j does, like you're jumping around different spaces, just doing some analysis, that's going to be really inefficient compared to just having a really fast way to rip through the data. Now with the joins, the problem is though, when you do joins in a relational database on graph data, is that you can have an explosion in the intermediate results after the join. So typically when you do join, you're kind of filtering things down. So I'm joining, this table's got 100 rows, this table's got 100 rows. I join them together based on some shared key, and I might produce 10 rows as the output. With the graph databases, what you end up happening is, you could have 100 rows, but then the output is 1,000 rows. It sort of blows up. And there's a lot of duplicate data. And so there's a technique that I don't think any system actually implements yet. DuckDB might have a prototype for this. It allows you to basically keep track of, like, I've seen this record before, and not materialize the whole thing, so that when you have these sort of exploding joins, you're not wasting a bunch of storage space and generating the same result. There are also other algorithmic advancements that are happening in the context of relational databases for what are called multi-way joins. There's a few systems that support these. Relational AI is the first one I could think of. There might be, DuckDB again might have a prototype, but I suspect most of the systems will have this in a few years. That instead of just doing a binary join, I got to join table A, do table B, and I only look at those two tables at once. A multi-way join allows you to look at multiple tables and join them together at the same time. And there's a really efficient way to sort of process them and reduce the complexity and the explosion of the overhead intermediate results. So that's, again, so you have what I was saying before, you have the separation between the physical and the logical layers. Logically, we can now represent graph queries using property graph query extensions in SQL. And then we also have a bunch of enhancements we can have in relational database systems to process now, on the graph data, because it knows it's processing graph data. So I would argue again that, like, if graph data and graph queries become a major factor in how people want to build applications, the SQL databases will pick these things up. Actually, the whole sort of the catalyst for how we wrote that "What Goes Around Comes Around" in a round paper in 2022 was because somebody posted on Hacker News. Some guy was like, I don't know why people even bother with relational databases. I feel like everything should be a graph database. Why aren't graph databases more popular? And I was like, oh, okay, this person doesn't understand all the reasons why relational databases are.
So you wrote the paper because someone was wrong on the internet.
It was literally, somebody was wrong in Hacker News, and I sent an email to Mike, and I'm like, we can't let this happen. Let's write the next version.
Excellent. Well, it's really interesting because while we kind of are at our core, a graph layer, because we are plugging in to all these different storage engines, all those storage engines are relational databases. So we ourselves, by doing so, are kind of still betting on the relational model. And I totally agree with your kind of overall thesis. Throughout the years, like the team I've always worked on, like my co-founders, we've been like all just relational databases the whole way through. Even doing things like full text search, we've managed to use like the ngram support and just really push it all into, honestly, Postgres at the end of the day, although we did use MySQL for many years. Cool. As we kind of approach the end of our time, I kind of wanted to leave things with whatever you think is your spiciest database take for the next 5 years. And I certainly have mine, and I can go first to give you a little bit of extra time to think. But I think the Postgres wire protocol needs to die. I think there's a whole bunch of databases. They're like CockroachDB, CedarDB. They're all re-implementing this Postgres wire protocol. We just had to do it for kind of our foreign data wrapper.
I've done it twice.
Yeah, and like this thing, people use the idea like, I'm going to do this because it's going to unlock all the client libraries that are written for Postgres. But what they don't realize is all of the extra complexity written in those client libraries they're trying to reuse is just working around a really shit wire protocol. And and so that is my thesis. I think if you want to succeed, especially since Cockroach has already spent a bunch of time kind of reverse, like there's no light at the end of the tunnel. You don't know how far you actually have to go in terms of implementing Postgres semantics. And I think Cockroach has kind of proven you can go indefinitely far and never be totally satisfied. So yeah, I think that just needs to die.
So, I mean, first of all, there's obviously two versions of the Postgres protocol. There's the text protocol and the extended protocols. You got to have both of them. And then the amount of compatibility, I mean, this is an interesting question of like, how compatible do you have to be to say you're, a drop-in replacement for something like Postgres? I mean, obviously the wire protocol is one, the SQL dialect is another, the catalog is another big one that people often overlook.
That's the rabbit hole.
And then you bring in the catalog and you got to start bringing in all the built-in functions and the semantics. Like it gets in the type coercion, it gets very, it's very tricky very quickly. I wouldn't say that's a spicy take. I mean, there's been papers written. The DecDB guys have one a few years ago that show how terrible it is. There's one out of Simon Fraser that shows how bad it is for getting data frames in and out of Python.
We still keep doing it though.
Yeah,
industry still keeps doing it.
And it's not to say that because we're not just dunking on Postgres. Like a lot of these systems are just equally as bad, right? Because there's just so much legacy code running with old versions of JDBC drivers and stuff like that. You have to deal with all that. We are actually having a talk this semester from the Columnar guys that work on Aeroflight in ADBC. So they're trying to push better wire protocols around the Aero ecosystem and a bunch of commercial systems. Like I know Snowflake supports native Aero. I'm sure Databricks does as well. Like that can solve for some things, but it doesn't handle. It's fine for OLAP. It doesn't handle everything you maybe need for OLTP. And I don't think anybody's really sat down and worked out better protocols. I know the Oracle and Microsoft have updated their protocols over the years, but again, there is no comprehensive paper research done on these things. So I would say it's a spicy take for that. Everyone kind of knows it sucks. It just there's not enough inertia, and certainly getting stuff in Postgres will be really challenging. I mean, just look how bad their like networking model has been, and you have to use a proxy in front of it, right? They're the only system that like has 20 proxy implementations just to deal with the crappy way they do networking. I've reached the point in my career where my spicy takes, I don't want to take a shit on any company because it's like, it's people's livelihoods. I mean, I can rant about Larry Ellison, but that's not really a spicy take at this point. So I think hardware is interesting. I just don't know where it's going next. Intel seems to be not floundering, but Intel's sort of in a moment where they're trying to collect themselves. The GPU stuff might be interesting, but like they're so hard to come by and they're expensive. At least the NVIDIA ones. So there's some stuff in the RISC-V world that looks interesting, but it's not like, none of that is like throw away your textbook. You have to rebuild all your system from scratch. Yeah, so I think maybe not in 5 years, but I like to see something in 10 years that radically changes how we do want to build database systems. The Optane stuff from Intel, the non-volatile persistent memory stuff, that was super cool, and I thought that could have been a game changer, but like that's dead. And
there's like a crazy third-party market for that now. People are like trying to buy old Optane cards on eBay. Yeah, yes. it's nuts.
We had a bunch of research on processing in memory chips. So this is think of like DRAM DIMMs where there's like little RISC cores on the DIMM itself.
Yeah.
That company, it was Upmen, and we have a paper coming out in VLDB next week on this. They just went out of business, and through this is being recorded, so I can't say too much. But let's just say before the bankruptcy, we were able to get a machine out of Europe. Cool. So the students could do research on it, but like that company's dead, and I don't think anybody is at near. Samsung had some stuff a while ago, but there's something new in hardware. I just don't know what it is. And I don't think it's just like, oh, NVIDIA makes this stuff more affordable. I'd like to see I'd be very interested in seeing a major upheaval of the von Neumann sort of classical architecture for database systems. But it will probably target AI stuff first. And the AI hardware that is out there doesn't seem to be, again, it's not radically different from, it's got specialized accelerators, but it's not radically different than like sort of classic architecture from the last couple of years. So again, that's not really a spicy take. It's just, that's more of a wish list. I think that would be.
I think that's spicy. I think it's spicy to say that like we need a completely new hardware design for databases going forward. All right. We're a little bit over time. I did want to kind of just mention that at least in our experience when it comes to hardware, we're a like totally ARM-based company, simply because we have a super parallel engine, and having real cores, you just get more actual real cores and not hyperthreads when you use a lot of the newer ARM hardware. So shout outs to ARM for kind of like working with us through that and moving industry forward with the new architecture. But I could totally understand how there's still way more room to experiment for hardware, especially for dedicated workloads. Thank you for your time, Andy. I really appreciate it. It was a super interesting conversation. Where can people find you? What do you want to shout out?
I do databases. Just Google Andy databases and I show up. No, honestly, we actually, let me promote one thing. This is actually serious. So as you said, we put all our course materials on YouTube on the internet for free. So if you're not a CMU student, you can watch the lectures and you can do all the projects and all the homeworks for free. I obviously can't give you any certificate or grade, but everything's auto-graded. Like there's a lot of people have done that, and I get emails from people that are outside CMU and they're like, oh, I've got a better job because of you, or I passed this interview and I'm going to work on this company. Maybe it's not databases, but it helped me be a better engineer. I appreciate that. I got an email this March from somebody who sent me an email that they were in prison and that they found my course and they were allowed to watch the course on YouTube, and it helped them really fall in love with databases and become a better person. And they ended up getting a database job. You might have seen this on Hacker News. He's in prison and he works for Torso, the guys that are rewriting SQLite and Rust. And I'm not saying that my course is how he got that job. He had to do a lot of it on his own, but that was really touched by his comments there. So what we're announcing this semester, we'll post on social media about this. If you are in prison, or if you know somebody in prison that wants to learn about databases, you send us an email and we'll send you our sort of a packaged version of our course to your prison, so you can learn about databases there. That's what I'm promoting.
That's awesome. That's great. I would love to see more like education work being done to help folks that don't otherwise have access to it for a variety of reasons, right?
And shout out to Convex, they're sponsoring this, so I appreciate them helping with this.
Cool. Awesome. Well, thank you so much for joining us today, Andy. Appreciate your time.
All right. Thanks for having me, man. Take care.
Bye.
See ya.
Hey, folks. First of all, Andy, thank you so much for that insightful talk and the spicy takes. Lots of good stuff in there for sure. And Jimmy, thank you so much for hosting that session as well. Folks, we're almost at the end of today's event. We have two small sessions, one a session on engineering philosophy, and also one about something cool that we are working on, that has something to do with AI. I want to quickly shout out a couple of things that we spoke about earlier today. One is we announced the launch of AuthZed Cloud. So if you want to sign up for AuthZed Cloud and want some cloud credits, oh, that's not the link. Just go to, let me pull that up. Yes, our AuthZed Cloud Starter Program, and you can get up to a month of free AuthZed Cloud credits. We also announced the launch of our OpenAI case study. Yes, we're working with OpenAI. The number 37 billion documents is somewhere in there in the case study. So do check that out as well. And Jimmy mentioned the upcoming, Jimmy mentioned that we are running our infra on ARM. And we actually have a webinar that's in association with the folks at ARM coming up in September. So for some reason, I'm not able to put up the link, but I'll have that up very soon in the chat. So, watch out for that as well. Okay, so going on to our next session. A couple of days ago, I actually recorded a small session with Irit, who heads engineering at AuthZed. And we had a great discussion about engineering philosophy at AuthZed. So we will go on to that session in a bit before we wind down. See you soon. Hey folks, I'm here with Irit, who heads engineering at AuthZed, who's going to tell us a little bit about the philosophy we follow at AuthZed in our engineering team. Irit, first of all, you have a lot of experience managing engineers and engineering teams. Tell us a little bit about the philosophy of AuthZed. It's a remote company. It's a very diverse organization. Tell us a bit about that.
Yeah, so as you mentioned, we are a remote-first company, basically with people spread across Europe, US, and Canada. We're very diverse, so different backgrounds, different opinions, different experiences. Everyone brings their own unique selves, and I feel that this is really helps kind of bring more innovation and more diverse solutions into the engineering space, and beyond that to the business world itself. Everyone is empowered to bring solutions, ideas. I believe in a bottom-up approach. Like, I don't believe in top-down leadership. I really believe that when people feel empowered to own their own solutions end-to-end and basically drive the initiatives, then we reach much better results. So this is basically the culture that people are driving projects end-to-end. They operate what we build. They speak with the customers and support them, and basically looking at what the customer needs and what are the pain points, and that brings them ideas on how to improve and what exactly to build in order to create a better experience for the customers that are using the AuthZed products.
Okay. And Irit, I've asked you this even outside of this recording session, because I think you've had such a great, vast levels of experience, right? You worked at Red Hat before managing engineering teams. Now you work at a startup like AuthZed. When there's something like a new feature that's going to be launched, what's your thinking, right? In terms of process and, design reviews, architecture, but also things like, creating tickets and sprints and all of that, which are very challenging when it comes to engineering and building a product in such a fast-paced environment. So how do you think about that?
Yeah, so engineering management basically is the combination of people, process, and technology. So basically making sure that you bring a balanced approach to all of the three pillars. So finding just the right amount of process to achieve the results, and while also making sure that people are supported and empowered and get enough clarity into the goals and the direction they're supposed to follow. So when we ship new features, we are starting with what is the value that we want to bring to customers, and then going backwards. So making sure that we are focused on bringing just enough minimal value to be fast in the market and starting to get feedback, while also making sure that everyone understands the definition of done and being able to measure and track their progress to understand where engineering leadership can support them and how to unblock them and help the engineers accelerate the process.
Gotcha. All right. Okay. So we're going to change tracks a little bit, because it's been 5 minutes and we haven't spoken about AI, which apparently is a rule in the tech world. I have to ask you about that, Irit. So the use of AI, both for customers and for products facing externally, but also how we as AuthZed and our engineering team is adopting AI in our internal workflows and processes and tools.
Yeah, so I will divide it to two different tracks. So one of them is the external part. We are incorporating any AI features or our ability to support AI workloads within our product, and shipping different cool stuff for our customers. And the other track is our internal track, basically aligning with what is happening in the industry and how companies are adopting AI internally. And I can say that everyone in the company is using AI, so it's not only engineering. We are using Claude Code, and everyone in the company has access to the tool, and they're using it for their own creative ideas and solutions. And it's really great to see that adoption. I can say that with AI also, we also use the very bottom-up approach. So basically looking at let's start adopting it. Let's identify opportunities to improve our processes and being able to measure the impact, rather than telling everyone that they must use it and kind of have a more top-down approach. So we believe in a very responsible approach with AI. So basically, we are not letting AI agents to run wild and access different things in production, but mostly keeping humans in the loop, making sure that we are reviewing any outcome that AI is generating, that we are able to measure the improvement. I can provide a few examples. So one of the key things that AI helped us was to generate more test cases. So basically increase our test coverage. We started with some coverage baseline. We used AI to identify any gaps and basically generate test cases for the gaps that were identified. we did have engineers like completely controlling the process itself. So basically looking at where exactly it makes sense to add tests, reviewing the tests, seeing that if they actually fit in that space and or if they need some improvements, they were reviewing the code and inserting that. But it helped us accelerate the test coverage and shifting left any issues that were maybe missed and could be discovered in the later phase of the software development.
Nice. Yeah. And I think I can shout out something that you've championed in the company, which is this culture of learning and sharing. So whenever like an engineer, figures like a nice workflow or something with like the AI tools, it's always shared like on Slack. So I think everyone learns from it. Irit, thanks so much for sharing this with us, and folks, enjoy the rest of the event.
Thank you for having me.
Hey, final session of the day, and this is a short one. I have a very special person with me in this session. This is Sam. Sam wears many hats at AuthZed, but also happens to be employee number 1. So really has been there since day 1. So Sam, I guess happy AuthZed birthday to you as well.
Thanks.
Yeah. All right. So Sam's going to talk to us about MCP. That's something he's been working on. We have actually done a live stream of much before about like some early versions of MCP that we spoke about, but you have something cool to share with us, Sam. So go ahead.
Yeah. I can't believe that was already maybe 4 months ago, I believe. But I mean, MCP itself was introduced November 2024. But since it's kind of undergone a rapid progression in the last 10 months. And yeah, if I could kind of put some maybe human understandable themes to the different phases of MCP, I would say phase 1, the first version of the spec was essentially trust everyone, verify nothing. It was assumed that you would run MCP servers locally on a machine, and you're the only one accessing it, and so it was kind of the wild, wild west. And then it picked up adoption. Major AI providers started adopting the spec, and it kind of began what the next phase, which is kind of like the security awakening. It's like, oh, this is pretty powerful. This is not something we want just running wild. And so I think the next theme of the spec in March was, oh, we need real security now. And then after that, kept on growing. It exploded, honestly. And so the next phase, kind of marked by the June spec release, was trust no one, secure everything. And this is where kind of the first turn toward more mature security offerings, both for authentication and authorization, kind of were introduced to the spec. And where that brings us to today, which is really only 2 months after kind of that most recent phase, is that MCP servers and tools and resources that they expose are kind of becoming the de facto standard for AI agents to interact with business tools and kind of internal data. And so that just kind of elevates the reason why MCP is so important. And here at AuthZed, our mission is to fix access control. And so we have been looking at MCP for a long time, and we've been trying to keep ahead of the spec and trying to build things to help our customers and the community to securely build MCP servers. So I think the time now is right where the spec is in place. There's enough guidance to be able to build kind of official hosted remote MCP servers. And the reason why we want to recommend people start doing this is that, one, if you don't do it, someone else will. If you have a product where people are using it and customers really want to interact with your data in kind of modern ways, people are trying to do it inside of their LLM chats. It's becoming something that people are really looking to do. And so if you don't have an official MCP server for your data, someone's going to build it for you. And you don't really know how they might go about that. And so the first thing I wanted to kind of introduce is we're releasing some open source reference servers for MCP. They were built with a few principles in mind. One is just easy adoption. Like I said, we think people should be building these now. And so the best way to do it from an engineer's perspective is to try it, get your hands in there, build these things. And so there's an easy way to clone a Git repo. You can one-click deploy it to Vercel. It's all built on open source technology, so it can serve as a foundation for kind of like building them up and turning them into production MCP servers. And they're all kind of assumed because we think that the spec will keep evolving very quickly. The assumption here is that you build them with the assumption that you're going to have to change them or throw them away and rebuild them. But honestly, with the advent of AI-assisted coding, our repos, the reference servers that we're releasing, are kind of primed for that. It's built with the statically typed language. The spec is well documented. Those two things combined with kind of an AI-assisted coding agent, it makes for really easy kind of building of these servers. And so I don't know if you have the slide ready, but otherwise I can kind of just shout out the GitHub repo name.
Yeah, if you can do that, Sam.
Sure. It's just github.com/authzed/mcp-servers-reference. And there's two servers in there that you can kind of explore. One of them in particular has a one-click deploy of a server that has both authentication and authorization built in. The authorization side uses SpiceDB to be able to secure tools. And we're going to keep adding examples in there so that it becomes kind of the first place you look if you're trying to roll out your first MCP server.
I'm going to paste the link in the chat so that people don't miss it out. Here you go. And done. Okay, Sam, so last question before we wind down. Everyone's talking about MCP as MCP is the new API layer, or MCP is the new REST. What's next, basically?
Mm-hmm. So internally, like I said, we've been looking at this for a long time. So the GitHub repos are great for people getting started and securing new MCP servers that you're building and you're releasing. But what about servers that already exist? There are people already who rely on existing servers that didn't have proper access controls built in when they were originally built. And so we are working on a proxy to be able to put in front of existing MCP servers and have them secured by fine-grained access controls. And so the MCP protocol has discoverability built in for both resources and tools. And so we're working on a way to use those APIs to be able to kind of automatically front an existing MCP server and have them secured. And then the ideal is that you could tie them into kind of a separate admin app where you're able to audit who's accessing what, as well as give like human in the loop approvals for different accesses. And the last thing I wanted to shout out for what's next is that we've been working on what looks like, what an AI native AuthZed experience look like. And so we've been building out some official AuthZed MCP servers of our own based on the repos that we've released, the reference implementations. And so we're really excited because actually just a couple weeks ago, the official MCP SDKs released some new features that we really want to incorporate. So we've kind of huddled again and really been trying to build out kind of like best-in-class MCP servers for AuthZed users and customers.
Awesome. I'm super looking forward to it because I think this is a space that's been evolving at such a rapid pace, and adoption also is pretty widespread. So yeah, I'm excited about it. All right, folks. So we're done with all of the sessions and all the things that we had to speak about. I'll wrap it up, but before that, I just want to give thanks. One, I want to give thanks to everyone here who watched with us. Yes, this includes all of you AuthZeders who are shitposting on our internal Slack. Thank you for staying with us through the entire stream. I also want to shout out our customers. A couple of them joined us for this stream today, but all of our customers have been excellent to work with. And I also want to shout out everyone at AuthZed for making this such a great place to work for. Here, shouting out the next 5 years. And maybe we'll do another stream then as well. Just to recap all of today, one, we launched AuthZed Cloud, which is kind of a big deal. And we also launched or announced the Cloud Starter Program. And if you want AuthZed Cloud credits, go sign up in the Starter Program. Hot off the press was also the second announcement, which was our partnership with OpenAI and how OpenAI uses AuthZed and SpiceDB for their connectors product. So that customer story is also live on our website, so check that out. Very interesting. And last shout out, of course, is AuthZed. Happy birthday, happy 5th birthday. And I'm excited to see where the next 5 years will take us. From everyone at AuthZed, thanks for tuning in, and we hope to see you soon. We do a bunch of live streams right here on YouTube, so join us here or on Discord to chat with us. Enjoy the rest of the day, and